What?
Hello?
Hi, hello, thank you. Thank you. Did you just do that to see if thank you. Yes, I was trying to make sure that the recording, everything was working for this. I'm stalling slightly. Did someone say hello for another reason that hello, hello. If there was more to the hello that I'm not acknowledging, I apologize. Okay. Oh, and all right. So you guys are amazing. There's a lot to discuss and a lot to do. The I'm aware. Whoops, sorry. I mean, so we have like this exam, which presumably, sorry, I'm just trying to. Okay, exams never make me a calm person. I'm not very good at. I get very stressed by exams and all of that. I mean, more when I'm the student than I'm the teacher. But anybody who does not like exams, you certainly have my sympathy, to say the least. That doesn't mean we're not going to deal with it and everything. I think though, well, I have a lot of things to ask you guys about what you've had access to, et cetera, but it does seem to me now pretty evident that most people received, even if it was much later than they wanted to, which I'll address, but I think that most people know that the bulk of the solutions to the exam were sent on Sunday in a long PDF, but then also as a recording. Like I went over the exam step by step, most of it, and made a recording and posted it. And it seems like most people are aware of that. And of course, I'll give the details again, but I've been putting all these recordings on Vimeo, but then finally I had a breakthrough. And I know that many of you are aware that now the recording for the exam, as well as a bunch of other maybe helpful recordings, got put on YouTube. And, and I saw that a bunch of people checked that out, which is fantastic. Like, even just to know that that the whole exam, the practice exam, to be clear, I'm saying, I went over almost all of the practice exam or stuff that hadn't been solved, and it tried to go through it slowly and carefully, sort of. And I think that most of you know that you can find those solutions now if you need them or want them, either in a PDF or in that recording. Now, I didn't give you very much time to deal with them. I know that, so we can discuss that. I'm open to what the possible implications of that are. But before we get to logistics, like just assuming that there's this exam that we soon have to take at home, and assuming that we want to understand everything as best as we can going into the exam, I think the most efficient way that I can answer some questions and stuff today is in a moment. And we're not going to deal with the exam the whole day, hopefully, although I always say that, and something could change. But I don't want to deal with the exam the whole day, but I definitely do want to deal with the exam first. What I want to do is put you guys in breakout rooms for a little bit, just so that you, without me in there, can quickly come to some agreements amongst can trade sort of your progress so far. And what I want in the breakout rooms is for you guys to come up with, share your thoughts and come up with a couple of concise or concrete questions per room that you want to see me address today, like first thing. Questions about the practice exam. Okay, let me try to make this even more. So I'm going to put you in breakout rooms to come up with sort of the best questions that would best use our time for the most people today. And I think it's best if you discuss that without me there. So it's not a matter of you trying to worry about how much I think you've studied or not. Let me be as clear as I can now. I'm saying, I'm going to hope that once you go into the breakout rooms, that everybody will at least share with each other like the links and stuff, and that everyone will make clear to each other that you've got these solutions being talked about by me and being printed on paper. I don't assume that you have gone through all of them by this point. I don't assume that. But I assume you've done some studying, and there's some things that, you know, hopefully you've figured out a way to consult those solutions for specific areas that you've had. So what I want you guys to go into I want you guys to go into the breakout rooms and sort of like ask each other quick questions like, I don't get this. Do you get this? Do you think he's going to put that on the like the stuff that you would do in study groups? But within a limited amount of time, come up with a couple of questions that you guys can ask me in front of the whole class. I know, put them in the chat or something. Your goal is to come up with the most efficient questions possible. In other words, if questions that can be answered in as little as time by me and clarify the most, right? So you don't want to come out of the breakout rooms and say to me, can you go over problem one? Like, that would be fair. I totally think you deserve that, but like I've tried to do that on the video already, so I don't want to waste anybody's time literally just going through something. So I'm already doing that. So you're going to go into breakout rooms. You're going to come up with concise questions like, on page 24, is it possible you made an error, Yaverbaum, when you blah, 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 you know, on this line, like, or see this line of the solutions, you put a negative. We don't understand why there's a negative there, something like that. By the way, there is no page 24, so that would be an error right there. So the questions that are, if you can frame multiple choice or true false questions to ask for me, that will force me to answer them concisely, and we can do as many of them that way more. I will be more clear about exactly what's going to be on your real exam, like what I'm going to take out. Well, I'll say one thing right now. Right now, don't worry about fluid drag. It might have confused you that I sent you fluid drag things in the middle of this, but that's because you deserve to get credit for learning that. But don't worry about fluid drag right now. Do worry about what's in the practice exam. And don't worry about the very, very, very last question in the practice exam where even though the very last question about gravity vectors, you don't have to worry about that. So everything else is fair game. So if this,
Before
is this,
breakout,
oh yeah, go. Yeah.
Logistically,
Yeah.
we're getting it at 4, and when is it ending?
Right, very fair question. And okay, so let me be totally, the answer to that question like the official arrangement answer is you're getting it 4 and you have until the beginning, like the first moment of class on Wednesday to turn it back. Like the official idea here is yes, at the end of this, and 4 is a slight exaggeration, say 5, but right after this class all dissipates and everybody leaves, and then I've had a moment to think or adjust things. Around 5, you get the exam, and then you would have till, you know, you have to submit it by the beginning of class Wednesday. That's the answer to a very fair question. But to be honest, after we go through some questions, and well, I'll say this to everybody, part of the reason you're going to go in the breakout rooms is I'm willing to adjust that, like to postpone things a little bit, to give you a little bit more time to go through all this because I put the solutions up late. I'm willing to hear that, especially if after the breakout rooms, people assure each other that, you know, yeah, we can ask him this and we don't all, you know, he'll still think, yeah, we've studied, but we can ask him this. You can. So that might change. We might, you know, I might give you a little bit more time on this exam if needed, but that's the official answer right now if nothing changed. Does that make sense? Does that? Okay. Well, yeah, we'll get to that. So other, other logistical questions like that, or can we, all right, I'm going to put you in the rooms. Again, you're trying to just share with each other, like make sure everybody should know that really now the full, almost all of the exam I've gone over. That's on a YouTube thing, which is easier for some people to deal with. So if that's not clear to some of you, please, some of you share that with others, but I know a lot of people checked it out. Also, again, please make sure there is a PDF of the solutions that you should have from Google Classroom, like share amongst yourselves. So again, yeah, you're going to come up with questions Oh, and I'll even also admit two things that are definitely on the exam that I feel like I haven't really fully finished. Like I would expect that there would be questions on where I was going with that whole gravity tunnel thing. Like we wrapped up the end of it very fast. So, but it is on the exam. So you could certainly ask about the gravity tunnel, and same thing with dot and cross products. I know there's more to say about them. So those are areas I'm totally open to, but any area really. Okay, breakout rooms coming. Four sounds good. Okay. So please go to your breakout room as soon as you're invited to. And again, we'll come out of them somewhat quickly, but I won't come out of them until everybody's gone. At least everybody's been in them for a little while. Okay, great. Thank you. I see people are already going. Great, great, great. Thank you, thank you, thank you. Okay. So again, so all of you who are here should be in bigger. Oh, thank you. Almost all of you have joined. You, are you around? Can you hear me? Robina, can you hear me? Alejandra, can you hear me? If anyone
Yes,
can
we
hear
can
me?
hear you.
Oh, thanks. Oh, great. Okay, so did you see that invitation to go to a breakout? I know you just got in. I know. Do you see like a invitation to join breakout 6 on your?
There's like a little.
Could you? I think you just did it. All right. Thank you. Great. And Robina, can you hear me? Yu, can you hear me? Hello, Robina. Hello, Yu. Hello, Robina. Hello, Yu. I'm going to embarrass myself by turning it into a poem. Rabina. Okay. Okay. Oh, Robina, can you hear, or you? Robina, can you hear me? Can anybody hear me? Okay. Okay. Richard, you here? Oh, Richard, is that you? Good. Robina? Hello, Rabina, is that you? Rabina? Hello? Hello? Okay, it's a little strange. Okay, is there anybody who can hear me? Because if you can, I would love you to go to the breakout room as assigned. I feel like there's audio issues happening with Rabina. I think maybe either you cannot talk, but you can hear, or the other way around. I think you can't hear. Oh, yes. Oh, weird. Whoa. I see what's happening. Okay, excuse me. I see what's happening. I see what is it. Whoa. Hello. Hello. Hello.
What the fuck? Did you hear that?
Yeah, I did. That was weird.
So,
Hello. Sorry to interrupt. Can you, sorry, this is Yaverbaum. Can you, I'm totally interrupting. First of all, can you guys see me or hear me? Do you see that I'm interrupting?
Yeah,
Okay, sorry to interrupt. I'm actually largely just here to see if everything's going fine, and if you, I mean, if you're good, I can move on, but I'm just checking that everything is fine.
yeah, we have a few questions. So, well, right now we're talking about dot and cross product. But one question that we didn't get solutions to yet, or that I'm just like a little bit stuck on, was part C of homework 5. It was the very last part of the gravity tunnel question. Where it was asking about if instead of going through the center of the Earth, you were just going through a chord. And I was wondering if you can apply the same equation for force of gravity to that scenario, or if how you would change it to apply to a chord versus going through the center.
Wow, fantastic, perfect question. Okay, perfect question. I didn't even mean, now I may not fully answer it right now because I'm first trying to collect questions to sort of prioritize them, and then I'll answer for everybody. But that one, I will, that's a high priority question. That's a great question. And it also reminds me, I want to send you a diagram in a second. I'll send everybody a JPEG that helps a lot with that. The quick answer though, to not leave you in suspense, is you do have to adjust. The interesting part of that question is you do have to adjust the gravity equation. You have to sort of pretend that you're on an inclined plane. Like, this is sort of a half hint. I mean, I will fully answer this in a couple of minutes to everybody, because again, great question. But just to maybe start you right now, like if you're in the diameter and you're falling toward the center of the Earth, that means the center of your tunnel is one and the same as the center of the Earth. So like you're being pulled to the center of the Earth automatically, and that in the diameter case would mean that you're being pulled towards the center of what your tunnel is. But if you think about an arbitrary chord, again, I'm saying this fast, like just because you deserve a response, but I'll say it slower a bit. But if you picture an arbitrary chord in some circle that doesn't go through the center, if you think about that arbitrary chord, it's like at a slant or a tilt relative to any radius that does go to the center. In other words, an arbitrary chord is neither horizontal, like if we think of vertical as meaning toward the center of the Earth and horizontal meaning perpendicular to that, then any random chord that doesn't go through the center is actually like a slide. If you think about it, it's like tilted with respect to our ground or to our vertical. And so when you're pulled on a slide, you don't get pulled with mg so much as mg sine theta. I'm saying that fast from like physics 1, but if that rings a bell, that like on an inclined plane, it's only a component of gravity that pulls you along, mg sine theta. That's the kind of adjustment that you will have to make, and then it will lead to something interesting, but that's a hint. But great question. I'll totally answer it for real to everybody. Is that okay for now?
Yeah, that was perfect.
Okay, great. Thank you. All right, so I'm going to move on. But yeah, this is what I'm looking for. Great. If every room gives me like one question like that, then we're going to close the rooms and I'm just going to answer those 5 questions because perfect. All right, so I'm going to move on. Okay. All right. Thank you. I don't know how to move on. I'm just going to stand here and be awkward for a while, if you don't mind. I'll just discuss my mother, my ethnic heritage. Hold on, I'm sure everybody will be. I actually literally don't know how to leave. Oh, yes, I do.
Yaverbaum, before you go, I
Yes.
keep trying to like look through the notes that you posted for the solutions, but I don't know if I'm the only one that's having difficulty like trying to figure out where the answers are in all of your notes.
Oh, yeah. All right, that's a fair point too. So in other words, the document, you did find the document, you have document, but it's actually very hard to go through the document and make any use of it. Is that a fair, that's like you have the document, but you can't, but it's hard to deal with. Is that right?
Yeah. So like
Yeah.
how you initially had posted the review exam and how you put like the answers in there, I found that a lot easier to navigate.
You know, that's very interesting. That is also totally fair. And actually, I have this dilemma all the time. I think that's good to know. And I think I agree with that too. Like, I'd rather have, in document form, I'd rather have what you're saying. And I may be able to get you that in time for the missing things. Like, it's sometimes a question of which I can just do faster or whatever. But depending on what we do with this exam, I may be able to then fill in the rest of the exam and give you solutions in that form. Because again, I do agree that's actually easier. And I do appreciate this feedback because it's helpful, like blah, blah, blah. The one thing is, to be honest, I scooted that PDF out when I realized the clock was ticking. It was easier, faster for me to do that PDF that way as while I was making, what I'm trying to say is I agree that PDF is kind of useless. It was actually meant to just help with somewhat until the recording came to you. It's just, I kind of like the part of the recording, which I think has its own value to hear me talk about it. But I completely agree. For a written thing, I guess what I'm saying is I wouldn't worry too much about that PDF now that you have the recording, but I will try to get you the answers that you like in the test document itself. It's just sometimes that takes longer to do. But if nothing else, yes, I will. Let me think on that. I know you're right. I will. The question is whether I can get that to you in time for this exam, but I'll at least highlight what all the answers are by the time we're done today.
Okay, that's perfect then.
Yeah. Okay, cool. All right. Thank you. And remind me when I get back to the group. Like, that's totally makes sense. All right, I'm going to run away before just because so the other groups don't get into chaos. But these are good questions. I'll be back soon, or I'll be back with everybody soon. Sorry. Okay. Sorry. Hello, guys. Sorry, I'm interrupting. I apologize, but can you guys see and hear me interrupting you right now?
Yes.
Okay. So hello, by the way, some of you, I definitely know some people in this room and it's good to see you again. One quick question, not to put anybody on the spot, but Rabina, you're in here, yes?
Yes.
Okay, cool. So sorry about the weirdness before, but everything worked, like your audio works and everything and you're good. Well, you're obviously, okay, good to see you. I'm just flying through the rooms just to see if everybody is okay. Like if you're talking and working on questions or you have questions, then great. But I mean, I probably can't answer them right here in the room. I'm probably going to answer them to everybody, but do you want to ask me anything or give me a sense of if you're doing okay? Or
I have a question. So like on a test, do we have to like do it exactly your way of doing the work? Or because like for the last part, for the Victor part, I can actually get the answer by just doing distribution and just knowing that I had this one.
great question. Oh, sorry. Go on. I'm sorry. Go on.
Or do we have to like do it your way in a video, like how you taught it in the video?
Totally fair question. Totally great question. And please remind me, I should answer this in front of everybody in a minute. The first main answer is no. I mean, or yes. If you can do something a way that works, you do it the way that works, especially if it works for you. You don't have to do it my way. I mean, if we both get there's no dispute at all. If you do a bunch of work and it gets the right answer, the same answer as me, then absolutely that's fine, even if it's a different way. I mean, especially hopefully I know that other way, even if it's not the way I'm teaching. I might have opinions of why I like my way better, but that doesn't matter. If you do it a right way and it's right, no problem. The little two qualifications I'll say about that is, or maybe three. Number one, it would still apply whether you're doing it my way or a different way. The most important thing is that I believe that you really understand what you're doing. So often, in fact, not doing it my way is the way that people show that like they get it, that they really get it. And that's why they have to do it their way, because they really get it their way. I'm all for that. If you really get it, ideally you would still get my way and know why you like yours better, but I don't even, right, it doesn't even matter. If you get your way and you can do it, that's cool. But just please understand, everybody, when you write stuff down, whether it's my way or a way that you got from the internet or a book, of course, if you write it in a way that makes it clear that you're just like I know you already who's asking this question, so I already know it's not an issue, I think. But there are people in this world that won't do something my way and do it a different way just because the different way is what they happen to get from Wikipedia or a textbook, and they don't look closely enough at the question to even see that really the reason I'm doing it my way is that they've misunderstood the question and they have copied something and misapplied it. Like, you wouldn't do that. That's not what you're asking, I know. But to everybody, I'll say, like, yeah, I would rather see an original, like a believed version of something that isn't me than a copied version of me that the person doesn't understand. So long answer, but you don't have to do it my way as long as your way actually works. Oh wait, sorry, the other caution was, make sure it does actually work. Sometimes people do other things other ways and get the right answer for a coincidence, and that I don't care if it's not my way, but if it's wrong, then I'll say it's wrong, of course. So for that, let me ask, one part of your question I didn't hear. Which particular part of the exam you're talking about where you did it a different way? I just want to make sure that I know what you're talking about.
Lecture part, the last part.
The last, oh,
Part
the
5.
the-
Part
the-
5.
part 5 in the exam, the wait, part 5. But I thought I didn't give a solution to that. You mean the gravity thing? I mean, which, read it out loud if you don't mind for a second.
The the dot product and the cross product part.
Sorry. Oh, so yes. Oh, especially cross products. If you do cross product a different way, like with a matrix or something, fine. I think you said something, you just distributed. Yeah, and if you distribute it, right. I'm also, a lot of times I'm trying to show people how to understand something for the first time. So of course, your way may be much shorter than mine. You may, if you get, yeah, I mean, cross products, as long as, I mean, I'll go over it anyway, but right. As long as you're getting the answer and you have a system and you get it, for cross products particularly, there's many different systems, so no problem. Okay, I'm just looking before I lose. I'm trying to find my exam before I, where the exam is. Why is it? Oh, sorry. Any other questions in this room you want to try to ask right now, or let me know of so I can bring any other?
I think that's it.
Oh, cool. All right. So you guys are, so I'm, all right. So I will, well, I guess I'll just ask you per, no, I won't. I'll move on. We'll all gather a couple minutes, but cool. Thank you for, but by the way, if you want to, if anybody in the room is weaker on cross products, since I haven't talked about it, and if you're strong, please help the other, you know, vice versa. But okay, I'm moving on before the going.
Thank you.
Thank you guys. Okay. Okay, is anybody with you? So everybody's in the rooms. I'm gonna try one other room. Am I? Okay. That's that. That's that. Oh, diagram. That's it. That's it. Um, oh, okay. Hello, hello. Okay. 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 Oh, I am so dumb. Wow. Um, pardon me. Okay. Even, pardon me first. I was about to start again. I was excited by a moment of technological discovery, and I was crushed simultaneously by another discovery, which is that I'm echoing because, oh yes, because I'm an idiot. Pardon me for a second. No, it is because I'm an idiot, but it's in a very subtle way. Uh, hmm. Wait, am I still okay? Can people hear me? Can people hear me? Oh, yes. Okay,
Yes.
great. Thank you. Okay, great. Okay, okay. Um, so let me let me. So I've got some great questions. I'm gonna try. I want to answer some of the questions that I heard in there, but I think I want to hear a couple more before I try to, so I could sort of triage or prioritize or whatever. So I heard from like breakout room 2 and breakout room 3 in breakout room 6, I think it was. Does anybody from any other rooms want to, can you either just ask right now or put in the chat one or two of the questions that came up in the room? Again, I want to sort of see the questions and then answer them in a particular order. So if anybody wants to either just put in the chat or raise, here I'm looking, right, great. Ah, yes, the gravity, great. Yes, already I'm seeing one question. This is, even knowing that one question is asked twice from 2 different rooms is such a strong indication of something. Yes. Finding omega alpha graph. Oh, that's a good one. Yes. Okay. If you want to keep in, I'm going to keep these, I will still take a couple more. Please feel free to write in a couple more questions from your group or whatever. I'm going to start answering them now. One thing is, yes, from a number, and this is great. These are the kind of questions that people ask when they have been studying, not when they haven't. I mean, to be like, I appreciate this sort of, what about the last bit of gravity question has come up a number of times. So let me please look, before I start saying anything about gravity, which is, I think, looks like the first thing I'm going to talk about here. Before I start saying it, there's a picture that I put in the chat, a file, a PNG. And first there's a PNG and then there's a JPEG. They actually are 2 different things, maybe in the weird order, but the picture is meant to be the best possible explanation or organization of information to allow me to answer the end of the gravity problem. I think what people are calling part C. So I am going to back up a couple steps on gravity because I know I was rushing it at the end the other day. And I'm going to answer this. In other words, what a bunch of people in rooms asked me is, okay, we think we get the gravity thing. We think we get what you're saying will happen to a rock if you drop it in a diameter tunnel. And that is what I'll review in a second. But then you, Yaverbaum, ask, what if the tunnel that you drop the rock or the particle in is not a diameter? What if the tunnel is of arbitrary length? It's just an arbitrary chord that just cuts from one bit of Earth's surface to another bit of Earth's surface underground. Then, I, Yaverbaum, ask you, then what happens? Can we make any sense out of that? And so people in the rooms are asking me, like, what do you do with this question? The picture will show, but that's what I'm going to deal with now, but other what other things do people ask? Oh, but one overarching question that someone asked that's really good to know too. When you take an exam with me, once you take this exam, do I care if you solve a problem in a manner that's different from what I put in the solutions? Like if you do it a different way? No, I don't. In fact, I'm thrilled in many circumstances if you solve a problem differently from the way I did, assuming you get the right answer, right, of course, and assuming that the way you solved it was right, like not a coincidence or not a misunderstanding where 2 wrongs led to a right or something. But if you and assuming that the techniques you're using are like within the realm of reasonability, like it's not actually fair to suddenly, invoke a quantum mechanical discovery when you're trying to like build a ping pong table. But right, within reason, if you solve a problem totally differently from the way that I did, that is great. That is great. And you will get full credit, assuming that you did that because you understand that way better, and assuming that in your presentation, your authentic understanding comes through. Like if it's clear that you know what you're doing and you do it a different way, that is great. Whether that means you ignored me and never paid attention, but because you already had it in hand, or because you made a choice, you like your way is more clear than my way, that is fine. That means you're really getting it. And that will come through. That is certainly far better, in fact, than just copying my way when you don't understand it and just hoping that by copying it'll be okay. So you can do things a different way. The one thing I would caution everybody is occasionally I've had experiences where people don't like the way I'm doing something because they think it's too complicated. And then they find what seems to be a simpler way to do something, which I'm all for. But the reason they found it is because it actually was to a different problem and they misapplied it, or it reflected a misunderstanding, or it did something. I guess I've already said this, but don't, sometimes a lot of things in physics are complicated, but they're always intended to be the simplest possible thing we could do. Nobody likes unnecessary complexity. The question is, what is necessary? So just be wary if you think you found a silver bullet, that may not be the case. But anyway, do things the way you want. The more you can show personal understanding, I don't care if it didn't come from me. I just want people on this earth to know enough physics so that I have people to talk to at parties. And that's you guys. Like, it doesn't matter if you get it from me or not. I just want you to know physics. So that was one good question. We're gonna do the gravity. Was there another question like that? There's questions about timing and logistics. We'll get to that, but was there, I don't think there was a, all right. So let's talk about this gravity thing. I'm gonna try to, all right. Like, to back up a couple of steps, what we know. So this is gravity and the gravitational tunnel. Okay. One thing one caution for this. Gravity is a force function is a vector function. Vectors are very important in this class. You see in the other problems, we're trying to deal with vectors very explicitly with dot and cross products, blah, blah, blah. But however, right now, to do this gravity problem, the vector nature is not actually operating in a big way. So I'm going to ignore that right now. For, I'm just going to write some equations and not get all bogged down in direction so much, because it's not the focus of the problem. Sorry, excuse me. So in other words, every equation I write down now that I'm going to use is really an equation discussing magnitudes, magnitudes of vectors rather than vectors themselves. Well, in other words, we know. Okay, the beginning assumption of this whole thing, right, is that the equation that we're used to, GMM over R squared, which always has a negative sign before it, like, because it's an attraction, that equation governs over point masses, particles. Like, that's all we know from the exact law, is what one bit of mass does to another. If we want to do anything more complicated, like a sphere or a shell or a cube or anything, we have to ultimately regard complicated bodies as collections of points, right? So ultimately, we have to sum up gravitational forces to get the net effect from big bodies. But what we found doing that through tricks, through symmetry and superposition, we find, we found assuming okay, we're assuming what we found, and this is me saying, like, there's work that went into this all in a lecture from a couple days ago and in the homework, but we went through a bunch of steps and found that if you have a solid mass sphere, like solid, whose radius is given as constant capital R, whose total mass is given as constant M, and whose density is given as rho, and we take that to be a constant, right? Given all this, we found that the gravity force function doesn't operate the way it does between 2 point masses. We found this, right? This sort of special gravity, if you like. We found, okay, again, strictly this is the magnitude of a vector equation, but we found, in other words, that once you're inside a solid sphere, anywhere inside a solid sphere, separate a variable displacement lowercase r from the center of that sphere, we found that as a function of lowercase r, the gravitational force, i.e. your weight, actually increases in direct proportion to your radius from the center as you get farther and farther out from the center, as opposed to decreasing as a function of r squared. So it's very, very different force function, right? But then we found this, again, that's work like that, and that you could be tested on those steps. But we found this, and then we realized, oh my God, even though this is a function, a force as a function of displacement, it doesn't say anything about time at all. But if we look at it, we realized, oh my God, this is just like Hooke's law, just like the things we've seen a million times before. In other words, we said, and I know, again, this is slightly review, I'm backing up a couple steps to bring us up to. But since we know this, and again, I'm leaving out the vector symbols, then we know, and I can go back if anybody asks me to, but we said, oh my gosh, it looks like within a solid sphere of mass, we could say something like this equals ma, right? If there's a tunnel or something, you know, so if the only force acting on you within the solid sphere is gravity, you know, we call that free fall. If you're free falling, highly unrealistic sounding so far, to be sure, but if you're free falling through a tunnel through the center of the Earth, so the only force on you is gravity. We found that this is true, but then since we know this, again, we're almost up to where this question is. And it's good, even if you think you know all this, just writing it over and over is just really good for the soul, honestly. The more you want to know without having to actually try to memorize, the more you just write things over and over. But anyways, we had this. So then we said, oh, we said, and then suddenly just by flipping the left and right side to make it more like it's looking familiar to me now, but maybe to make it really familiar. And again, I can go back to that page if you want. And again, writing this down is valuable in one way for people who do not think they understand this yet, and it's valuable in a different way if you think you already do understand it. But we got this. And we said, oh, mama. No, we didn't, because that would be weird and inappropriate. But we said something like, oh, shucks. Look at that. R is we've never seen R before in this class, but R is just a letter from the end of the alphabet. It's some kind of dependent variable here where T is the independent variable. And look, we have that the second derivative of R with respect to time apparently is equal to some negative sign times some constant times R itself. So we said, oh my God, this is simple. And I know, again, the people asked me the question today about gravity. Probably get this much so far, but we said, oh, this is simple harmonic oscillation. Who saw that coming? Like I didn't. I mean, I don't see any metal coil or anything in the middle of the Earth, but apparently we have this. And therefore, now we're getting almost to the other question. If this is simple harmonic oscillation, and if, oh, yes, I'm sorry. Yes.
Is there also mass on the side of
Oh,
acceleration?
Sorry. You're absolutely right. Thank you. That was about to get out. Thank you. I just totally left it out by accident. Yes, there's an M. There should be M on both sides. You're exactly right. But then they cancel out. So we have this. You're right. I'm off by but if I do that, are we in agreement if I make that correction?
Yeah.
Okay, cool. And that's a really good point. And the M that she's talking about, actually, I don't know. Was that Gabrielle? I'm sorry. Who brought that up? Who just said that?
Yeah, it's Gabrielle.
Okay, Gabrielle, thank you. Yes. And she's right. And just to be clear too, the M she's talking about that I dropped out by accident, the M of MA, always means the receiving mass, so to speak, right? When we say F net equals MA, we mean that all the forces acting on some object determine the acceleration of that object, little m. So in other words, what's canceling out here always is the falling object, so to speak, not the object toward which it's falling. That's why all objects of different weights fall at the same rate. But so that's just an extension of what Gabrielle's saying. I'm not saying she was crossing off the wrong one or something. But okay, so we have that now. So we say, oh, this is simple harmonic oscillation. And that stuff in the parentheses, oh, it's just right. The stuff in the parentheses, like that constant, the whole thing is, that's just a bunch of constants, but we always call that constant omega squared. Monday morning quarterback. Whenever we see second order time derivative of some dependent variable equals a negative constant times that variable, that constant we refer to as omega squared because we know that if it's an oscillator, a harmonic oscillator, we know that it will oscillate like this. Like we know this is a solution, and we know the omega, which is, of course, the omega must be equal to the square root of whatever is inside those parentheses. Again, just we call the constant omega squared because the discovery is that if something is a harmonic oscillator, then it will oscillate with an angular frequency, which is the square root of the constant in its differential equation. It's beautiful. And that constant, look, again, here, so I'm saying, I'm still sort of dwelling on the general case of this. I still haven't gotten to the actual question that someone's asking me today, but I just want to say, like, right, once you see a differential equation, you immediately know what the angular frequency is. And note here, it's like saying, it's literally like saying, it's like saying that omega equals square root of k over m. And in effect, capital G times capital M times over R cubed is like one big K, right? Like the stiffness of the inner Earth spring, the stiffness of it is determined by the mass of the Earth and the radius of the Earth and the universal constant. Oh, so just like that, I'm saying omega here, once again, is determined by material properties of the system. Omega is not determined by any way that you configure the system or anything you do to it. It's just determined by what it's made of, like any spring, right? So what we said, again, I'm just catching. So we can say, okay, omega. Oh, sorry. Yes. I'm sorry. Yes.
Just verifying, does that say that omega equals the square root of omega squared?
It does say that, which sounds redundant. Yes, it does say that. I mean, which is stupid. I mean, of course, like maybe it's a stupid thing for me to write down, but people get very confused that we always have that omega squared sitting in it does say that. And if that doesn't help you at all, if you already get everything else and that just seems like a dumb thing, then just leave it out. I'm just sort of saying that omega always is the square root of whatever the constant is in our differential equation. And that's why we call the constant omega squared, because you take the square. It's like this big awesome trick that we all now have. But I think that is what it says. It's kind of a stupid thing for me to say, but yeah, you are reading it correctly. So I'm now saying, omega, the angular frequency, is the square root of those constants there, those Earth related constants, which means necessarily, this is what I guess I'm doing, necessarily then F equals this, which means the rate at which, I'm saying if you drop, what this is really saying is if you make a tunnel through the Earth, which is difficult, but make a tunnel that's small, so it's not changing much about the rest of the mass of the Earth or anything like that, but just enough little bit of a vacuum space to drop something in. We're saying, if you think about it, when you drop something in that tunnel, if it goes all the way through the Earth to the other side, it's going to be pulled towards the center. And if you drop it from rest, it's going to speed up falling towards the center. It's going to be getting faster and faster and faster, like anything when it's falling. But unlike regular free fall here, if you think about it, the proportionality of the force it experiences is based on R. So as it gets closer and closer to the center, the force of gravity pulling it gets lighter and lighter. Like we said, in the extreme case, if you're literally dead center at the Earth, I don't care if you're a Volkswagen or a truck, like you weigh nothing. If you're at the center of the Earth, gravity is pulling not at all. And it pulls on you stronger and stronger as you get farther out. So as you fall in, you're getting faster, but at a less faster rate. Your velocity is building while your acceleration decreases, i.e. your kinetic energy is building while your potential energy decreases. Like you'll act just like a mass on a spring. You'll reach a maximum speed at the center and then lose speed as you move your way out towards the edge, but gain acceleration and go sloshing back and forth at some rate, which is this right here, this standard frequency. So we can go one step further and convert it to something really realistic and say, then the period with which you would go back and forth would be the reciprocal of that. Would be the reciprocal. And I know this is just about where we left off before, but the reciprocal is this. And then now, minor technicality, but just because this problem is sort of a classic, the period, what does it mean? Period means how much time it takes to do a cycle, like a full round trip. So technically, if we plug in, not technically, really, if I plug in numbers here and spit out a number, that number is going to be the amount of seconds, the number of seconds that it would take a rock to go all the way to the edge of the Earth and then come back, right? That's what period is. But the question we were actually interested in, the question we were asked is, we want time to the other side, but not back. We just want to know how long is it going to take to fall to the other side. So we really want, just because that's what the question's asking, we really want half of the period. right? It's just a language thing, but we actually just want to know how long half a period takes. So it's not, so we're going to divide both sides by 2 and say that to get to the other side would be pi times r cubed over. Okay, now we're almost at the heart, at the like the really the twist part that everybody's asking about. But this, everything I'm saying here would be true of the Earth, of the Moon, of Jupiter, any solid sphere, right? All of the relationships I'm saying are true of any solid gravitational sphere. If
Can I ask another question?
yes, please.
So would half the period, like the time of it, be the same thing? Like if we would solve for t in the equation of r equals r naught cos omega t, if
No, keep talking. I'm sorry. Keep talking.
the diameter,
Wait. If we solve for lowercase t in the r naught cosine omega t thing, if we solve for t, then what? I didn't miss the after part of that.
then would it be the same thing as finding the period over 2?
Really good question. Really good question. But it depends. Solve for t in that equation, setting what equal to lowercase r.
Well, would lowercase r be the diameter of the tunnel, which is the diameter of Earth, runs through the center?
Okay, let me think about that. Oh yeah, if we set it there, oh yeah, it should. Right, that's a good. I was actually getting set to pick something apart with that, but no, I think right. If assuming that you say that r naught is like the radius of the Earth, like the thing starts at the edge, and then you say that r on the left hand side of the equation is right, in fact, like 2r naught. Oh well, then yeah, then yes, that it should be the same as solving for t in the cosine equation. That should be if you wait, but you don't know. But do you know? Yes, you know. Yes, I agree. Did you do that and it didn't work, or you
No,
did that? And
I'm just wondering. So
oh,
you would have to set r naught equal to, like, what would you set them to?
right, and that's in a way. I was just about to do that in a way, but I would say, in fact, I'll write your thing clearly on the next page in 1 second. But to answer it, you would set r naught equal to the radius itself of. You would set lowercase r naught to be equal to capital R. That is, you want the initial position of your oscillator to be the edge of this solid sphere. You want it to start all the way out from the center. So you would substitute in capital R for the lowercase r naught. And then, like you said, on the left side of the equation for lowercase r, like how far are we tracking it? We would plug in effect 2 times capital R, because you want it to go a full diameter to the other side. I may have just said that too abstract. I think I'll write that down in a second for you, but I want to finish this thing before I get confused. But does that make sense?
Yeah, thank you.
Okay, cool. So, but to everybody else, I'm sort of doing the very related thing right here. I'm saying, to catch us all up, like we just got a general expression of how period relates to this particular oscillator, this gravitational oscillator. So now let's try to put it in perspective for a second. Let's say that this solid sphere we're talking about here is an idealized like Earth, right? In other words, for capital R, for the radius of the sphere, let's plug in the radius of the Earth, which I'm about to tell you and about to do. And for the mass of this whole thing, let's plug in like the mass, just to get perspective on these numbers and what we're saying. And then also so that I can really answer the question people are asking me, which is super cool. So if we plug those in, then, i.e., so let's like apply to Earth. Okay, this is the part I just said last time, but I didn't actually do, but it is just a plugin. I'm saying then what we're going to find, and I may or may not have time to write out what Gabrielle was just asking, but she's definitely right. What I'm saying then is this, but I'm going to plug in is that what it is? 6.9. And the mass is, why am I suddenly? Oh, yes, okay. And So the radius of the Earth is approximately 6.4 times 10 to the 6 meters, like 6 million meters, which, by the way, has been known since about 150 BC from one of the great physics experiments of all time. Like, don't believe the hype about people used to think that the Earth was flat or something. I mean, some people did, some people still do, but they've known the Earth was round since before 200 BC, and they've known exactly how round it was because they knew how to measure shadows. But so that's the radius. That's how round the Earth is, and how big it is approximately this big. How big is it? It's so big that when it sits around the house, it really sits around. Okay. The mass of the Earth is approximately 6 times 10 to the 24 kilograms, which is very heavy. How do they know that? They actually know that because of plugging into the universal. We actually know that because of GMM over R squared. In other words, if you believe you know the radius of the Earth and you drop an object and you time how long it takes to hit the ground, that's all the facts you need to get how massive the Earth is, which is kind of nice. But so I'm saying here in this context, those are the numbers we're plugging in. Oh, sorry. And one other number you need to know, you never need to memorize this or any of these. These are given on the front of but it's good to be familiar that the universal gravitational constant, that does not change from any one point in space to any other. And so far as we know, it doesn't change in time, but maybe it does. Over long periods of time, maybe it changes, we don't know. That's that. So we're gonna plug in. And pi is a number even on your calculator, so I just leave it as pi. But well, actually I shouldn't, because I'm going to chop off digits on the others anyway. So, okay, that's approximately 3.14 times. Now I'm writing, this is just plug-in, but this is hard to do. You can easily mess this up on your calculator if you're not careful because of all the order of operations and scientific notations and stuff like that. But at least this is what you want to do on your calculator. And sorry, it's illegible, but I'm just plugging in the numbers that I just wrote on the prior screen. So you've got R cubed in the numerator. You've got G, which is a wacky number, times M in the denominator. Then you square root the whole thing. Then you multiply by pi. I'm telling you that when you're done, you'll get some number that I think is 8.64 times 10 to the fourth or fifth. Don't quote, but I'm not sure. I can never remember what number you get right at this step, because whatever you get, let me make clear, is going to be in seconds, right? If you think about it, all the numbers we just plugged in were in meters, kilograms, seconds, or we plugged in G, which is all based on newtons, milligrams, kilograms. So if you just do this straight up, you plug in all the numbers, you're going to get some big number of seconds. I'm going to ask you to divide that number by 60, because then, so we can relate to it. If you divide by 60, or in other words, or sorry, do the thing I said yesterday, multiply by 1 second, multiply by 1 minute over 60 seconds, just so that we can get a number we relate to. If you do that, you will get approximately 42.1 minutes. Like, that is definitely the answer to this. We're still not done with the gravity. But, and I know I wrote it on the JPEG I just sent you, but it's important. This is an annoying enough computation. You do want to check on your own, because this is the kind of thing on the test. I'll ask something just like this, but of course I'll give different numbers, like the number on the moon or something. Make sure that you can actually do this on your calculator properly. But if you do it, you should get that it takes 42 minutes. Now, I'm about to get to the part people are asking me. I still don't think I have, but just to be clear where we are so far, what I think we've just proven is something interesting but unrealistic. I think we've just shown that if you dig a tunnel out through anywhere from one point in Earth to anywhere straight across on the other side, you know, when you get rid of the air and friction, blah, blah, and you drop something, it should take 42 minutes to get to the other side, and then another 42 minutes to come back. If it, and 40, that's pretty fast to get to the other side of the Earth. Why do we not? Oh, a good question. Why I didn't bring the 2 to the other side. I should. If I'm solving for t, I would bring the t to the other side, but actually I put the 2 there because I'm on purpose. If you read the English of the question, and I don't mean that sarcastically, but like the question is asking how much time does it take to get to the other side of the Earth? That means we're solving for a half a period. We're not actually solving for t, we're solving for a half of a period, like not a round trip, but a one-way there trip. And if you do it correctly, you'll get 42 minutes. Now, that's fast. I am saying if I dug a hole all the way to China from Brooklyn or whatever, New York, you know, and I did it properly, which I cannot. I'm saying if I did that, I'd drop a rock, it would get there in 42 minutes. Of course, that's preposterous. Like, of course, nobody's digging a tunnel through the actual center of the earth. I mean, there's molten lava, nickel, cadmium, alloy, like at thousands of degrees. Like, no one goes to the center of the earth. Obviously, it's ridiculous. First of all, there's death and fire and brimstone and 7 bulges of circles of hell there, or something related. But also, there's friction. So it would mess up the whole problem anyway. I know it's super unrealistic to imagine a tunnel going all the way through the center of the earth. But now comes the question that I asked, that I do want people to know about, that people asked me in the breakout rooms. The next question is, okay, what if we're realistic? What if the tunnel is not a diameter, but rather an arbitrary chord? Now that opens this field. That's a much more realistic or interesting question then, because we're saying, what if you make, like, what if here's the earth, and granted the earth is not a perfect sphere, and granted there is all kinds of frictional effects and fire and brimstone, like at various portions of the earth. But we're saying now, what if you just dug a tunnel like from this point here, this is a horrible drawing, but to just like here, right? Like you went under the surface a little bit, like a subway tunnel. Like, and you went from Brooklyn to maybe you went from England to France, or maybe even just Brooklyn to Queens or something. What if we did a short tunnel of unknown length? Could we carry over any of our findings to that? Now, I'm going to say the point of the diagram, now I'm going to answer something that is in the practice exam that I've not said yet to anybody. People in breakout rooms asked me about this. Sorry to take so long to get to it. But this is the most almost worthwhile, interesting part. If you have an arbitrary chord, what that diagram's trying to say is you definitely have to make an adjustment if it's an arbitrary chord. If your chord that you're dropping something in and evacuating, if it's more realistic, which means, by the way, that we can probably evacuate, like you can make tunnels where you take out the air as long as the tunnel is, you know, not too steep. We're saying if we have something like this now, like that kind of tunnel that doesn't go through the center, okay, this is now a different ball of wax because if a line that goes from the center to the edge of the earth is called a radius, any radius by definition is what we call vertical, standing here on the surface of the earth, right? When we say something falls down, what we mean is it falls down toward the center of the earth along a radial line, whether you live on the east coast of the United States or if you live in Australia or China. Down means toward the center. So the vertical line to us, the y-axis in our life, is the gravitational line, the radial lines of Earth, wherever we're standing. And anything perpendicular to a radial line, which is not how I meant to draw that, honestly. Anything perpendicular to a radial line is what we call the floor or the horizon or a horizontal line, right? If anything is perpendicular to a radial line, it's on the ground, wherever we are. And if it's parallel to a radial line, then it's vertical. If you have an arbitrary chord like this, if you think about it, what you really have is an inclined plane, right? You have something that is neither vertical nor horizontal. An arbitrary chord, whoa, that's some arbitrary handwriting there. Right. An arbitrary chord, I never know how to spell chord in this context. I apologize. But an arbitrary chord is an inclined plane. That is the center of the earth to which gravity always pulls is not the center of the tunnel now. You're being pulled by gravity along a slant relative to your tunnel, right? If you're driving this tunnel, it's still a tunnel. It's still falling down. If you look at either edge of this tunnel, it's pointing somewhat towards the center of the earth away from the surface. So if you made a subway tunnel from Brooklyn to Queens or Brooklyn to England or whatever, it still constitutes a drop if you put something at the edge, but it's not a free fall drop. It's gravity is pulling you somewhat along only one component of gravity is pulling you towards the center. In other words, I'm saying the center of Earth is no longer identical with center of tunnel, i.e., I'm saying what really pulls on us is some component of gravity, what you might be used to calling mg sine theta, okay? Sorry. So for anybody, so you do have to make an adjustment. I'm saying now, so now, in other words, the relevant force of gravity is really more like this. If you remember from physics 1, that along an inclined plane, you know, the component that pulls you along the plane is mg sine theta. That's literally what I'm doing here. I'm not going to, well, and the redraw of the exact picture of exactly where I got sine and why this works is the picture I put in the chat. Hopefully you can find and download or whatever. But that, now we're not done. That's adjustment 1. Now, okay, we're only a component of weight pulls us toward the center of the tunnel. Okay, so we made an adjustment to the force. We have to multiply by sine theta. What's the consequence of that? Well, it means that I'm no longer sure that I have a harmonic oscillator, or I'm no longer sure that it's the same. Where's the picture? Oh, good question. I put it in the chat of today, but so it's 2 files all the way up at the top of the chat, 2 files called, so they're like, one's a PNG and one's a JPG, all the way at the top. But I would like confirmation from someone they could find it, because I put it in the chat while you all were still in the breakout rooms. So maybe that means you don't get. Could someone confirm, if you look at the top, scroll to the top of today's chat? Oh, so no one, if no one can see it, okay, I'll do it again right now. Okay, I'll resend it right now. Yeah, sorry, I'm glad. Yeah, that's very good. Now I've learned something too. So when you're in the breakout rooms, I couldn't even send you money if I wanted to. Could not. There's a number of reasons I couldn't send you money though, actually. Hold on, I'm gonna send it right now. One of them is, of course, I don't have any. Hold on. Where's send? Wait, everyone. Okay, it's coming. Bear with me. I apologize. I think it really helps speed things up. I'm trying to send something to you. I think what really helps more than anything is if I mutter sort of irrationally to myself. That tends to speed up. Okay, one hopefully just came, and then I'm going to send something else which is related. Okay, tell me if, hopefully you just got a PNG and a JPEG in the chat. Maybe not the best way for me. I'll try to remember to do it in Google Classroom too. Well, is this okay? Could someone confirm? Thank you. Okay, thank you. No, thank you for telling me that. That's great. Again, the PNG is what I'm really talking about right now. And actually, it is transparent. So it may, tell me if you need a white copy of it. But this JPEG thing that I sent was more of just the excerpt of the proof that I just did. So only one of these is an image. But the image, if you look at it, it's trying to show that when you have an arbitrary chord, you really have an inclined plane. So you have to adjust the force of gravity that we found, like adjust the force of gravity that we found, the GMM over R cubed thing. We have to take like that's our new weight. That thing is what our weight is now, but we have to take a component of it. So what does this mean? Well, I don't know. The good and bad news is there's one other adjustment I have to, I mean, I do know, but I don't know yet because there's one other adjustment I have to make. Like the first adjustment I just made was the force. If you have an arbitrary chord, the center of the tunnel is not the same thing as the center of the Earth. That's like a new thing we have to account for now. So the source of the pull is not your destination, okay? But I just said that. That means there's another adjustment. It's also the case that the distance, the displacement really, I always do this. Anybody who knows how to, okay. The displacement from edge to center of tunnel no longer is no longer identical with displacement to center of Earth. Okay, this sounds like I'm saying the same thing again, but it's actually two distinct points that's going to make all the difference. This is point number two. Sorry. Point number one was, I'm just going to scroll back for a second. Point number one was, once we recognize that the center of the Earth is not the same as the center of the tunnel, point number one was, sorry. Point number one was that the source of the force is not the same as the center of the tunnel. But point number two is now that the source of the displacement, or the target of displacement, the origin of displacement is not the same as the center of Earth. In other words, we just adjusted the force because we had to. We also better adjust our displacement. The displacement, that is to say, let X, I'm going to make a new variable now. Let X stand for displacement from center to edge, well, sorry. Let X equal displacement from center to position in tunnel. Right now, again, when we were in a diameter, this, and again, everything I'm saying right now is new. Like, you may already understand it, but it's definitely not a repeat of anything I said 2 days ago. This is the first time I'm saying it. I'm saying that when we had a diameter tunnel, we were being pulled from the center of the Earth, and the center of the Earth was the center of the tunnel by definition. Now, we're being pulled still from the center of the Earth, but now the center of the Earth is not in the center of the tunnel anymore. So number one, that affects how hard we're being pulled. But number two, whatever we're tracking, this variable distance that we're slosh, that if this is a harmonic oscillator, the variable distance that you slosh back and forth through a tunnel, like around the center of the tunnel, like if that's what we think was happening in the diameter case, well, that displacement that you have from the center of the tunnel to wherever you are in the tunnel, that is not lowercase r, the same as lowercase r. Like lowercase r is how far you are from the center of the Earth, but the center of the Earth isn't in the tunnel. So in other words, if you look at the diagram, what I'm really saying is, if we care about X, if we want to explicitly care about how far you are from the tunnel, like X really is equal to a component of R, right? Like it's never as far from the center of the tunnel as it is all the way to the center of the Earth. To the center of the tunnel is some component of the big hypotenuse all the way to the center of the Earth, if you look at my diagram. So you're just going like one little leg of a right triangle when you travel this tunnel. So now what I've made is two adjustments, and we're almost done. I know this is a lot, but this was probably one of the biggest things I was hoping someone would ask me about today. And yes, it's on your test. I'm saying to now deal with the more realistic, more interesting, difficult case of an arbitrary chord. Oops, sorry, someone is, okay. We've had to be careful and adjust we've had to recognize no longer do we have the simple luxury of a center of tunnel at the same as the center of Earth. So we had to adjust two things. We had to adjust the force and we had to adjust the displacement. But now the magic that you might see coming, we did have to do all that. But now what we have then is, yes, yeah. What, right, we had to adjust the force. So I just did that with r sine theta. And now we're recognizing that whatever your position is at any moment that we care about, that you're tracking, what we care about is your position from the center of the tunnel, not from the center of the Earth. So by acceleration now, we mean relative to, or with respect to X, not with respect to R. So the differential equation we now have, you're gonna either love or hate this one. I'm saying this now. And then the m's cancel again, like Gabrielle pointed out before, the little m's cancel out, fine, that's great, just like before. And x, by x, remember we meant r sine theta. So what we actually have now is even better way I could do this. Sorry, that would be stupid. Sorry.
Theta
I'm
or
saying,
x?
sorry?
Is that d squared theta or d squared x?
Oh, thank you. That's supposed to be, thank you. That's supposed to be an x. Sorry, that was crossing something up. That's supposed to be an x. Thank you. Right. And that's what I'm gonna do right here. This is the fabulous thing. This is a subtle, this is literally a case of, not of cheating, but in reality, where two wrongs are making a right in a weird way. Like I'm saying, the minute you go to an arbitrary tunnel, you got two problems you got to face. One, your force is no longer right. And two, your displacement term is no longer right. But amazingly, if you draw your diagram carefully, they both change by the same factor, which is sine theta. Okay, this is not meant to be a circle to run you pointlessly. What it turns out is, oh my God, what I'm saying is, if you're in an arbitrary tunnel, you're getting less of the force and you're traveling less of the displacement, but by the exact same amount. So that what you end up having is, once again, a differential equation, not so much in R, but this time in X, right? But we had, like, in other words, both sides got adjusted by the same amount. So it's, again, the same differential equation. Oh, I guess I should, yeah, I could, we again have that same thing. Technically now it's in X's, not in R's, but who cares? Just like it was originally in X's with the springs anyway. We now have this. Not only do we have a simple harmonic oscillation again, which is a little bit more interesting because this is an arbitrary tunnel, but even crazier. So we have an oscillator again. Look in the parentheses, we have the same constant, right? That did not change. What changed was R to X, but everything inside the parentheses stayed the same and the T stayed the same. So if you go into an arbitrary tunnel now, what this is showing that in an arbitrary tunnel,
Can you go back to last slide for 1 second?
sorry, yeah, absolutely. I was just so embarrassed by my handwriting. I was going to sort of write it more, but yes. So I'm saying well, yeah, hold on. I'll just pause it. So I'm saying now, and this really is crazy, I think. I mean, this is like the kind of, I mean, it's like a long joke that I think it's long, but I think it has a really good punchline. All arbitrary chords are all harmonic oscillators with identical angular frequencies, right? Like, in other words, the diameter tunnel is blah, 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 R, blah, blah, R. And a non-diameter tunnel is blah, X, blah, X. But X and R both stand for lengths, first of all, different lengths, but lengths. But in both blah, blah, blah cases, what never got affected was the GM over R cubed in the parentheses. So what this really means is, therefore, changing our focus from a diameter tunnel, in other words, the special, easy, therefore unrealistic, that's the solvable case that is so simple that it's solvable, but so simple that it's sort of unrealistic and unsatisfying. We always start with that and we just keep tweaking and tweaking to try to get to more and more complicated cases. Like, that's what we do in physics. So when we went from the easy case to the diameter, and we're changing, that says changing, sorry, change, it still doesn't say anything coherent. It says changing our focus from the diameter tunnel to an arbitrary chord. What we did was we took the same oscillator. We took an oscillator with a given omega, in effect, a given K and a given M. Like, we took a spring that was so stiff, and if we move it from being a diameter case to making a small tunnel that just goes from like Brooklyn to Queens. What we're doing is taking that same spring and just setting it in motion with a smaller amplitude. Like the difference from between a diameter and an arbitrary chord is simply amplitude. It's like, and this goes all the way back to Gabrielle's question. The difference between a diameter chord and a regular chord, arbitrary chord, is simply what you're going to set as R naught in effect. It's just how far out your initial displacement is. But the angular frequency is independent of that because this is harmonic oscillation. This is chandeliers in the Sistine Chapel. So I'm literally, harmonic oscillators maintain a frequency. I'm just trying to write this as many different ways as I can. The frequency or the period of a harmonic oscillator is independent of amplitude. A clock is a clock. That's what we're studying here, in effect, is clocks. Things that keep time without getting messed up by space, independent of amplitude. And if all this is really true, then that means that the arbitrary chord, omega equals omega, which equals the square root of omega squared. I'm saying for the arbitrary chord, then T equals 1 over F, which is to say 2 pi over omega. Am I being crazy? Isn't that right? Yeah. Right. Which in this case is going to equal, I don't know what that thing is, which in this case is going to equal 2 pi over, just like it did before. And that means that T over 2 will equal pi times, just like it did before. And this is a typo. And that means I am literally saying, and this is why I think this is all worth it, because I think this says things about gravity and harmonic oscillators that are fabulous. This means, literally, it means, can I dig a tunnel through the center of the earth and like live to tell about it? No. Would I propose to the United States or to Japan? Would I go up to anybody and say like, hey, dude, I'm a physicist. You know, have you considered like doing a subway system through like the third bulge of hell, like in the center of the earth? Like it might be really cool. Like, of course that, no, nobody's considering that. Nobody should. But what this math says is that you dig a tunnel from Brooklyn to England, like under the water, or Brooklyn to China, or Brooklyn to Queens. What this says is if you get the air out, and you can do that for small tunnels, if it's worth it, the money, you can dig out a tunnel and drop a rock on one side. And what this says is, if the tunnel is really big, the rock will move really fast because it'll have a lot of potential energy and therefore gain a lot of kinetic energy on average, right, when it zooms through the middle. If the tunnel's really small, then there's a short distance to go, but there won't be a lot of potential energy and not a lot of acceleration. Then on average, a rock will travel more slowly based on gravity, and everything works out perfectly so that whether you make that tunnel go to England or China or Queens, and if you carve it out and drop something in, gravity will get it to the other side in 42 minutes, no matter what. Like that's the conclusion of this. In other words, short story long, in order to deal with the arbitrary tunnel and make all of this worth it, both mathematically and financially, like worth it as a practical thing to consider, which people have. Like, I'm not making this up. It is not actually cost effective in the long run, apparently, but you can make a subway system based just on gravity all over the world with all these tunnels, and all of them would just be guaranteed 42-minute trips, is the point of this. Because they're all simple harmonic oscillators of the same material properties, but different amplitudes. That's what this is really trying to illustrate. And it is the case because we had to go through all this work to make 2 adjustments to our simpler case of gravity to see what would happen in the complicated. We had to make 2 adjustments, but we find that the 2 adjustments perfectly mitigate each other, and we get this result. Okay. There's one other, I got another, before I forget, I had gotten another question in a breakout room about how can you read omega straight off a graph, as I do in another problem. I hope not to forget that and to address that next. But before I do, any thoughts? I want to let this sink in for a second, but this is like the full Monty of the gravity problem. This is the most I'd want you to know about it. I do want you to know this, but this is the extent of it. Questions? I'll have just Antonio, and then I'll head up.
Okay. I was just gonna
Anthony.
ask.
Sorry, not Antonio. Anthony. Sorry.
Or I go by Antonio, whichever one you want.
Okay.
For theta, I'm looking at the image right now.
Okay.
I get why like the theta, it's like in the triangle, I get why that makes sense because like one side's pointing to the center of the tunnel, the other side is pointing to like where your object would be. But what is like the theta on the like chord with that line? Like is that line sort of just arbitrary, or
Oh, great
like
question.
how do you get that line?
Right. No, great question. Right. So you're asking about the theta between the sort of blue dotted line. Like, how did I get the black dotted dashed line
Yeah,
from?
exactly. Yeah.
Right. That's a great question. That dashed, a perfect question. That dashed black thing line, what that is, it's not arbitrary. Right. It's necessary and it looks like magic. But what it is meant to be the line that's perpendicular to the radius, to the orange radius. Like if the orange radius is defined to be a radial line pointing from wherever you are in the tunnel, to the center of the earth, then the black dotted line is meant to be a line that 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 intersects with your blue tunnel, but which is definitively necessarily perpendicular to radius, i.e., that dotted black line is supposed to be the ground, like the horizon, like that's horizontality. If the radius is verticality by definition, if anything pointing to the center of the earth is what we mean by down, is vertical, then a line perpendicular to down must be the ground or the floor. And I'm drawing that because just sort of to try to relate back to physics 1, then like that's usually the line from which you measure the inclination angle of some inclined plane. Do you know? So I'm saying that's the
Oh,
horizon.
okay.
Like,
So yeah, no, also I didn't see like the little right angle symbol on it.
oh,
So
sorry, yeah. Okay.
that wouldn't the black line, would it like change? Would it like like as you move, as like the object say moves, it would
Right.
create, oh, okay, that makes sense. All right, I was
Yeah, no,
wondering that.
that's a great question. Yeah, but yes, I mean, what you're saying to yourself is right. And that's the beauty. Like, that's why, like everything else in physics, why once you're all said and done, it all seems to make sense. And it like almost seems like, oh, well, it should be obvious. But right, the subtlety of that all working out in that diagram like that is exactly why none of this is obvious. But yeah, you got it. The fact that, sorry. Yes, no, go. I'm sorry. Go.
Very related question. So for the same picture, I'm having a hard time seeing that if you were to move the star along the blue dotted line,
right,
like wouldn't the thetas not be the same?
That's a very good question. The thetas would not be the same as each other, or
Yeah,
as
as
they
each
were a
other.
moment ago.
As each other.
Right, and that is definitely related to what Anthony or Antonio was asking. But I think I want to say that they would. I think they would. Hold on, let me think of this thing. Like one, like. Well, I mean, certainly the one near the center of the earth would, and the one that seems like it wouldn't, I think, is the one from the blue line. But let me think. How can I say this for a second? The easiest way to see, I think the easiest way I can answer this, I think the best way I can answer it is if we back up and look at the extreme case of what this diagram is trying to say. Like, in other words, if you actually did, like, we'll go to both limits. If you go to the limiting case where you were actually falling through a diameter, like it should fit this diagram, but just be a simple. In other words, if you actually were falling through a diameter, then theta should be 0. The theta near the orange line would be 0 necessarily. And do you also agree? And I know this doesn't answer your question yet, but just starting off in the simplest case, like if you were falling through a diameter, do you see how at any random moment both thetas would be 0?
Yeah, I see that. But
okay,
I just meant for this picture.
No, right. I totally agree. But I'm just, because I do think it's, but if you even take that one step further, and then if you agree that when you're falling through a diameter, like at any moment, both of them are 0. So in other words, like they are, that means that they're, that it's possible to fall and keep the angles in step with each other. Like if we now go to the diagram itself, as you're falling down the blue, as you're falling along the blue tunnel, the reason that the angle between blue Yeah, here's what it is. I know exactly what I want to say. I think it probably seems from the picture that as you're falling along the blue line, perhaps you could imagine how the theta next to the orange line would change, but it doesn't seem like the theta between the blue and the black should change. Like, in other words, when you fall down an inclined plane, nobody thinks that theta changes while you're falling down the plane, which is why this is a good question. But if you're falling along the blue, right, that means the star is moving along the blue. That means the orange line moves with the star, and then the black dotted line also would tilt to stay horizontal with the orange line. So in other words, I just happened to orient the whole picture so that I could make that black dotted line look actually horizontal to you right now at this moment. But if you look like parallel with the top of the page. But I mean, if the star is falling along the blue, the theta that is between blue and black is supposed to be the theta between the inclined plane itself and whatever ground is. But ground, horizon, horizontal is not that means perpendicular to the orange radius. So if you slide along the blue line, the black line also has to change with you while you're sliding. That's why both angles would change while you're sliding. Am I making sense or no? You can be honest.
Yeah, that makes sense. So like
really?
by our definition of what the ground is, that's always perpendicular to that orange radius.
Yes, perfect. That's exactly what I'm saying. Yes. And the reason I even like the way you put that. I mean, it shows you definitely do get what I'm saying. And I want to say to everybody, this definition of ground that I'm saying, like everything else in physics, I promise there was a moment way into my physics education where suddenly I was like, oh my God, horizon, horizontal, ground, oh, perpendicular to ground, oh, perpendicular. Like that never occurred to me until it did. So it's okay if it didn't, and I'm not saying it didn't occur to you, either of you two, but I am saying I'm not making that up for this problem. Like that definition of ground is what we mean by ground in general, and that's why it's fair to apply to this problem. But yes, those two people are clearly looking at the same diagram I am. If they're asking those questions, like those are great questions. And just because I talk a lot to answer, people can still say like, no, I still don't get it. Like that would be okay, but it sounds like they do. And this is crazy. I mean, people should ask me about this because I am literally saying that physics is saying you freaking make a tunnel anywhere from any edge of the world to the other. Again, Brooklyn to England or Brooklyn to China or Brooklyn to Queens. I don't know why it always has to be Brooklyn, but and no matter what, it's a 42-minute drop. I mean, I think that's a crazy result. And of course, you know, some realistic factors can make it a little bit less crazy, but it's only a little less. Like, so it's worth like challenging this, I guess is what I'm saying. But other questions on this gravity business. Oh, I'm sorry. Why do I care on this exam? The real takeaway. Well, first of all, we have to know about gravity for the next exam. I promise we're going to go somewhere with all this gravity stuff. But also, you really need to see, I'm really trying to emphasize harmonic oscillation means period or frequency independent of amplitude. Like the more I can drum that in, that's what this example is trying to do. But okay, sorry. Either follow up from either of the two people whose name begins with A or anybody else?
I have two questions. So just putting into like a mini summary of what you were just talking about.
Yes.
Difficult to follow, but the thetas, did you say they do wind up changing or they don't wind up changing?
Right. Oh, no, fair. Right. I'm saying every moment that you fall, both thetas would change. Like they do change from moment to moment, but they stay locked together. They both change in the same way from moment to moment. That theta, those thetas are both always the same angle, just because of geometry. That's like not because of some fancy gravity thing, but yes, I am saying both thetas change together, so they always stay equal.
Okay.
Does that make okay?
Yeah. And then in your notes that you were writing before, I'm not sure if it was a sort of typo or if you were trying to include, and I think it's on a previous.
Okay. I keep getting very careless and fastness with the M, so I'm sure you're quite right. It's very possible. Is it like here or something?
Yeah.
Yes, you're absolutely right. There should not be that. Thank you. That should not. And anybody she's absolutely right on page 19 of these notes. And this is Gabrielle's original point. You're right. I keep sometimes forgetting that M that cancels out. Yes. But that's good.
These
are good questions. Really.
I also have a question. We
Okay,
said
yeah.
before that x is the displacement from the center of the Earth to the variable, like to the position wherever you are in the tunnel, and that it
Yes.
equals r sine theta. But looking at the diagram, I'm just confused because r sine theta is not the distance, like it's not measuring from the center of the Earth to the tunnel.
Oh, no, right. That's my point. No, okay. Then okay, so looking at the diagram, you're right, quite right to apply this to the diagram. Somewhere in the English, either I just accidentally typo agreed with one of your typo English words, or I typo English something. Because what I'm saying is, if you look at the diagram, I'm saying that if x means the distance from the star to the center of the tunnel, like if what we're tracking always, what we care about is like, how far am I from the center of this thing? Like if we're trying to think of it as an oscillator or whatever, then if x stands for the distance from wherever you are at any moment, which is the star, to the center of the tunnel, like your equilibrium position, so to speak, if that's what we mean by x, then I'm claiming that that's equal to lowercase r times sine theta. In other words, okay.
So it's just like a word that.
Yeah, it's not. If I said I'm trying to make it equal to the center of the Earth, I said that by accident. That was my mistake. What I'm trying to do is, we already know about the center of the Earth. I'm trying to now apply it to the center of the tunnel. So yeah, I'm saying it's the sine theta, like the opposite side in that right triangle. I think you get it. Right. These are great questions, really, really. And again, every time I say something's a great question, it is not because I do not believe that there's no such thing as a bad question. I believe there is a such thing as a bad question. I don't know if someone asked what I would do, like I try to be, but these are not bad. A bad question is like, what does your mother think about this? That's a bad question. Like there's no excuse for that. But all right, well, I think, there was one other question about this, and then I do know what we're gonna do next. One other question someone asked is like how, it's not about gravity. I mean, I'm assuming I'm going to act like we're good on gravity for the moment. On a related thing, someone asked how to read omega from a graph. Very good question. And by graph, I assume we mean a graph would be where time is on the horizontal axis, as I put in your whole part one of your practice exam. The kind of graph we're talking about here is if time is on the x-axis and if some dependent variable, whatever it is on the other axis. I'm just gonna call that z for the moment. Like in other words, assuming some arbitrary, generalized, dependent variable that someone's thinking might be in harmonic oscillation. And if we have a graph that looks something like this, right? So this is supposed to be a z. So I'm using z on purpose to be arbitrary. So like if we have something like this, the question is how to read omega from a graph like this. Very fair question. And I think the question is coming up because in the solutions that I was talking through for this problem, I talked about reading from the graph of various things. I believe the easiest way to read omega from a graph is to not read it directly. And if I ever implied that you could read it directly, then I apologize for that. I would never try really to read. I mean, you can, but I would not try to read omega directly from a graph. What I would read is t and convert that to omega. In other words, I would look at a graph like this and say that, oh God, that's not anything. Sorry. I would say if I were looking at a graph where time is on the x-axis and the variable at hand is on the other axis, I would say that the interval along the time axis between any two like cycle points, in other words, between two peaks or two troughs or the middle to the next middle, that interval is a period, right? The amount of time to go through one cycle, to go from peak back to peak again, is a period. That can be read directly off the graph, I think, and that's what I usually do. And then what I would say is I would take that and say that omega must be 2 pi radians per cycle over the amount of seconds per cycle. So you get radians per second. Like, so I don't think, I would not actually read omega directly off a graph. I think I might have started implying that I was going to do that in the solutions, but I would read T off a graph and then convert to omega to answer. I forget who asked me that, but someone asked me a good question. I'm going to say now it's 310. Of course, I said we weren't going to deal with this all period. And of course, I always say that. There's still dot and cross products perhaps to discuss. I will say again, though, I've now posted, like, I think I've made like 4 separate videos of kind of the same thing on this. I'm still, that's not a substitute, but you definitely can find me talking about dot and cross products until you're bored to tears. But I haven't talked about them fully yet here. And that's why I want to now pause for a minute and say to everybody, I like the questions. I think you're studying. I think this is a good group. I think it's fun talking about physics with this group. Therefore, I think that if you talk amongst yourselves privately when I walk away and you come to the conclusion that if you had more time to look at the videos of the solutions that I posted, or look at the solutions, or look at what we did in class tonight, like before I dropped the exam on you, I would totally be open to hearing that. Like our constraints are these, or we originally put the exam for today because someone very wisely said they wanted last weekend to study. And like, so no one wanted it on Wednesday. That makes sense. And I think we all want to get this exam out of the way and done before we move on next week and stuff. I mean, I want that. But the truth of the matter is, like, whether you hand in this exam Wednesday before class or Thursday or something like that, or even Friday, doesn't change. Like, you would still get it back the next Monday, blah, 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 blah. I guess I'll make this concrete. We can leave the exam arrangement almost exactly the way it is. That is, you'll have it by about 5 p.m. today and then have till Wednesday morning to turn it in. One thing about that is we'll have class tomorrow and we won't, and this is a little bit of a disadvantage, we have to move on with material tomorrow. So I won't do this all tomorrow. You'll just be stewing through it, and that is whatever it is. But I'm perfectly willing, if you guys all tell me when I walk away, to say we can now just keep on teaching material. Like, I'll do dot and cross products now and then start with new material and stuff tomorrow. And we can say that I don't post the exam till tomorrow evening and you'll have to Thursday or something like that. I'm gonna make it concrete. Yes, I'm perfectly willing to postpone the distribution of the exam by a day. And what that would really mean, I would give it out tomorrow after class, then and then you would hand it in Thursday. Or even, I could even say, if you guys want, I could post it at the end of Wednesday and you have to Friday to do it. And the one advantage of that is that you're not sitting through a class talking about something else while you're worrying about this. I mean, I kind of like that. So I don't care if this exam doesn't come in until Friday. But if it jostles people to have a change, I understand that too. So here's what it is. I'm going to walk away. I'm going to turn off my video and mic for like 5 minutes. You guys talk. I think here's the 3 options. Keep the exam exactly the way it is. Postpone the distribution of it by a day, or postpone the distribution of it by 2 days. No matter what, you'll have the same amount of time to do it. All the same rules apply. And I won't change the material on it. I'm still going to be clear with you. Like, I'll be clear about that. I'm not going to expand the material on it, but it'll just change how you do it. So those are the 3 options. Keep the exam the way it is, postpone it by a day, or the distribution, or postpone it by 2 days. What I'm going to do is walk away. I want you to discuss and be frank with me when I come back. I'm not guaranteeing this is a democracy. I'm not saying it's majority rule. So don't try to bully each other. Like, you wouldn't, but I mean, like, everybody hear each other and discuss, and then tell me what people are thinking when I come back. Even if there's 2 people in the minority, it doesn't mean I'm going to, like, it doesn't say what I'm going to do, but I just want to hear people's feedback when I come back. Does that make sense? Okay. And I'm doing this partly because I think the solutions are valuable and I think you're using them well. And I think I got them to you kind of later than they could get their maximum use. So I'm going to walk away. Make sense? Okay, cool. Thank you. All right. So I'm going to give you like 3 minutes. Just talk amongst yourselves. Again, I'm turning off my stuff so I can't hear you. Sorry. Yeah. Sorry. What?
Verifying that I heard you correctly, you said either you distribute it today, we hand it in by Wednesday, or you distribute it tomorrow, we hand it in by Thursday, or you distribute it Wednesday, we hand it back Friday.
Precisely. Exactly.
But what time? For Friday or Wednesday?
Assume
or
all the, just to make it simple, let's assume the same time frames for all. So in effect, it's like when I get it to you by like for, let's realistically 5 p.m. on the day, and then you get it back to me by 1:15 2 days later. So it's like either 5 today and then you get it to me the beginning of class Wednesday, or it's 5 tomorrow and you get it by 1:15 Thursday, or it's 5 Wednesday and you get it 1:15 Friday. You see what I'm saying? That the timings will be the same. Does that make sense? Whoever asked, I didn't hear. Or okay. So I'm gonna but please discuss frankly with each other. Really. Poll. Oh yeah, if you do. Oh, great. If you're doing a poll, do it. I'll screw it up. But if you're doing a poll, great. And I'll look at it when I come back. But I'm not going to do it because I'll screw it up. So I will be back in a couple of minutes.
You guys, whoever made the poll,
I also work Thursday, Friday. So in terms of being able to actually sit down and do this exam, other than these next 3 days, I don't really got the time for that.
Yeah.
me too. I work Thursday, Friday. I think Tuesday to Thursday is a good choice.
I also have a final for another class on Tuesday, Thursday, so would rather take it today.
Yeah, honestly, like I'd rather just give it out, have him give it out today. The only thing we have to do between now and Wednesday is the post lab 3, which isn't that bad comparatively to like having the formal, which is also due Friday.
Gabby said as well.
Huh?
Like what Gabby said, how like if he could give us class time tomorrow, just because I feel like the options, like if we picked Wednesday through Friday, we'd obviously, for people who are not obligated to do anything, would have a lot more time because they're not obligated with class. But then at the same time, a lot of people work. So I feel like it would just be more reasonable if we got it today and then we had like at least half of the class period tomorrow to work on it as well. But
I agree.
Yeah, like if he could not, because the Zoom is so long, like if he just like canceled class kind of tomorrow and let us do the test, like we could all get it done.
Yeah.
But that's the thing. He will not give us half the class. He will not do that for us. So you guys have to understand that there's material we got to keep going through and that he has to finish.
I feel like he would be open to letting us have half the class.
Because he told us that tomorrow, regardless, he's going to keep going through the material and he's not going to stop.
Yeah, we only got like so much time left in this class anyway. Like
exactly.
We can't slow down.
He can't slow down. There's no way he's gonna slow down. So if you guys want it for today and hope for half the class tomorrow, I don't think that's gonna happen. But if you guys want it, the only reason why I want it for tomorrow, that just basically gives us an extra day, which is gonna be Thursday, and we don't have anything to do on a Thursday. Of course, except work. I gotta work too, but
yeah, that's the thing. Like pushing into either Thursday or Friday, I lose more day than gain because even though I'm sitting here in class, 90% sure I still have any of the exam to do. I'm gonna just be doing it in the middle of class.
Yes, I feel like the vast majority of us would do that. So then, Eddie sent a new poll.
Maybe
but then
give us lab time.
If he'd be willing, like he probably won't be, but if he would be willing, then we could like agree with getting it today and then having like some class time tomorrow to work on it, and then if not, like we could do like Tuesday through Thursday.
Definitely not. I definitely don't think Wednesday through Friday though. Wednesday through Friday.
Wednesday through Friday is a fat dub.
It's a fat no for me because like that's just no.
I won't have time to do the exam.
Me neither. I work 10 hours. I work 10 hours on what's it called? Thursday, Friday, Saturday, and Sunday. So I need those hours. So I think Tuesday tomorrow is the best date for him to give it to us personally.
And like the thing is too that they're still due at 1:15 any day you pick. So
yeah, exactly.
It'd be different if it was due later in the day of the option. Like if we moved it to like Thursday, Friday, but it was due later in the day, that I'd be okay with that because I could potentially hit that. But Thursday, Friday for me, 1:15, I'm at work. I have no time beforehand to get it done.
Honestly, guys, everybody got everybody's numbers. I mean, at least for the most part. This exam is not mission impossible. We can all help each other out. I think we should. I don't mind either or, but just not Wednesday.
Yeah, I feel like we should leave as is. Just, we've just gone over it. It's fresh in our minds. I don't know. That seems like the best.
I like the last comment, Brian. I agree with you 100%.
Yeah, he should give it to us today, but it should be due later at a later time.
Professor, would you consider giving us some class time tomorrow to work on the tests or no?
Oh, that's interesting. All right, I would consider a lot of things to be honest. Part of the hardest thing to consider is what the trickiest thing is how much we need the class time. I mean, in other words, part of why I do the take home and stuff and try to put the problem with using class time is that we don't have a lot of class time to cover all this material. That wouldn't be my first preference.
Professor, would you be open to the option of if we do it whether Monday to Wednesday or Tuesday, Thursday, whichever we choose, instead of maybe doing 1:15, is just do towards the later end of the evening?
11:59 p.m.
Oh, that's a very fair question. I mean, the other question is also fair. The other question is a little trickier for me. Now, that one, I often do that. I often have tests due at midnight. I have no problem with that at all. The thing about that is, and I'm happy to do that. I'm a little bit more inclined, though, that if it's due at a midnight of a night, the problem is if it's due midnight of a night where we have class, if we sit there and have class for 3 hours, and if I'm not dealing with the test that much during the 3 hours, like if we're moving on, and you still have the test festering with you, not due till midnight, it makes it very hard for a lot of people to focus. Like I resent being in a class where I've got something due for that professor, and they're just like going on and on about something else that I threw about later, but I'm all stressed about that thing. It kind of makes things awkward because then I know a lot of people are going to be spending that class time just stressing the test anyway, which will make me want to help them, but then I use up the class. So what I'm saying is, this is in fact part of the reason and I see that you guys are split and stuff, and I don't want to spend too much more time on this, but I'd be absolutely happy to have it due midnight. Like it could be due midnight Friday, for example, but if it were due midnight Friday, and I could even give you more time than I said, like it doesn't have to be just 36 hours, it could be 48, but I would do it midnight Friday if I was giving out the test Wednesday after class. If I gave out the test today, and then I make it like midnight Wednesday or midnight, then there's so many moments of class that we're all sitting there just supposedly listening to me, but actually stressing this other thing. And maybe I'm introducing another proposal. I mean, I'm happy to do it midnight Friday if we give it out on Wednesday or something, or even if we give it out tomorrow, I can make it midnight Friday. If we give it out tomorrow after class, I can make it midnight Friday. I do hear the people that are saying they want me to give it out today because it's still fresh in their minds. If I gave it out today, yeah, see, I don't want to then have 2 days of class while it's just sitting there festering. And I know nobody wants to spend this much time on this.
Because another consideration is that some of us work on the days that we don't have class here, and so even if that's the reason why I say for midnight, only because like during the Thursday, Friday, I wouldn't be able to submit it at 1:15. I'm at work.
Right. No, totally makes sense. All right, okay, I'm listening to all this, and I do, again, this input is all, I apologize if what I'm about to say will go against what some people are saying. I do apologize. It's not actually going to work perfectly for everybody, but having listened to everybody, and also, by the way, not only do you work, but wait, do you work? I don't want to ask personal. You're going to work electronically, or well, it doesn't matter. It's not a business, but like from yeah. All right. So yeah, I hear you. Like we have lives, that's for sure. So I think what I want to say is this: it's gonna maybe freak out some people that think this is still fresh in their mind, but I think in a way the best thing I could do is say that I give out this test at right after class tomorrow. I give it out right after class tomorrow. So, but then we have till Friday midnight. to do it. Like that would be sort of a compromise of all these constraints. I think it would not perfectly address those people who want to dive on this right now because it's fresh. It wouldn't address, but it would give a day more to assimilate, and then it would make it, well, I don't have to explain. I'm saying, I think what I'm very strongly inclined to now is that I give it out to you tomorrow, right after class. That means you still could ask last minute questions tomorrow and stuff like that, but then you'll have all the way till midnight Friday to hand it in. How about this? I'm going to walk away one last time, sort of quickly this time. I know I'm changing the game here, but that's like I want to see if people could basically accept that as a compromise. Again, I might do it even if you guys say, if a few people say, no, I can't accept that, I might still have to do it. And maybe, but if that's what's now I'm proposing as a compromise, and if you guys could I'm going to walk away, and if you could basically live with it as a group, then we're going to do it. But if I walk away and you all are like, no, that's exactly a misunderstanding of what we've been saying, what's that dude thinking? Then I won't. So I'm going to walk away for like 2 minutes, see what you guys think about. I hand it out right after class tomorrow. So you can still ask a few quick questions tomorrow, blah, blah, and you can study tonight and look at the solution, but then we have till Friday midnight to do it. I'm going to walk away. I'm not even turning off the video. I'm just going to walk away for 30 seconds, go to the bathroom. So, okay.
All in favor for Tuesday through Friday, say aye. Okay, I guess no. But yeah, Tuesday through Friday.
I mean, his compromise still works because I still get it Tuesday night.
Yeah, so it still works for you and me. I mean, I don't know who else works, but for Tuesday through Friday, we get that extra time. We get that 11:59 p.m. That's perfect, man. There's nothing I can't complain, honestly.
Yeah, that works for me because my issue is Thursday, Friday. My store's open, so I do have to go to work, like physically go.
Me too. I work in a furniture store, so I work 10 hours, 10 to 8. So
yeah.
I gotta physically be there too, and I gotta physically be with customers. So it's not easy.
Yeah, but having to do midnight Friday and getting a Tuesday night works perfectly, and it still gives time for like working on the formal.
Exactly.
But we also don't have to worry about. I assume we will be getting the post lab done tonight. So.
I mean, I'm not gonna lie. Me and my group, we already finished lab 3, formal, and the post lab. We finished everything, but it's just I want to do this exam right. That's it.
No, yeah.
Okay. I don't know who's in favor. It looks like, okay, whoever's in favor, at least just write aye, type aye, something in favor for Tuesday through Friday. Please, anybody, so we can just get this over with.
Everyone can just click on the.
There we go. There we go. Hey, okay. Yes. Okay, I think everybody's in agreement. Yeah. Yeah, everybody's in agreement.
Oh, sorry. Hello, I'm back. Sorry, I'm back. What? I just walked. So what? I just heard someone say. Sorry. So
I think everybody's in
we?
agreement on Tuesday through Friday.
Oh yeah, great. Oh,
everybody's
great.
agreeing.
I really awesome. I appreciate it. And you know the thing, and I know I sort of just pushed that through, but I think that's great. And one reason is because there was one other question somebody asked me in the breakout room, and I almost forgot, which was their question was, their comment was that the PDF solutions that I gave you all before the video was read, and I did that just in case the video didn't work, that they're very hard to go through those PDF solutions and like know which answers are what to what. So, and that's true. I said to that person, I will try to go back and put answers directly in the exam. Sometimes that takes longer, but this will give me time to do. In other words, I think this will give time to shape up the solutions and have everybody look at them more too. So I'll try to get you more clear solutions if I can before. But great. Thank you guys. That's very flexible. So we'll say Tuesday to Friday. That's the official thing. Don't violate. Oh my God, don't violate. Yeah, I don't even know what that. You can. Oh wait, sorry. Yeah. This is all true. Right. Okay, cool. Awesome. All right. So now we've got a few more. And am I right that you can see those YouTube links and stuff, right? Okay, cool. All right, we're done. I think, by the way, even now, we're actually, from here on in, I think these are live streaming on YouTube, which sounds so ridiculous. I think right now it's going to the wrong account. So, but I think once they are, then it'll mean that the recordings get to you much faster because they're not recordings. I mean, the links will get to you much faster. But so let's spend a couple minutes on the vectors, I think, is what's left. I think it's the next sort of big I think it's what people were asking about in the breakout rooms. Wait, is that right? Yeah, let's just wrap. Of course, I said we weren't going to do this all period, but we are. So let me, on vectors, again, there are a million posted things about this, but I think the main issue with vectors is the cross product, right? Okay, how about this? Can you electronically raise your hand if you feel pretty comfortable with cross products? I'll be more specific. Say on a scale from 1 to 5, where 5 is the most comfortable, 1's the least. If you're like 3 or above on cross products, 3 or above comfort level, please electronically raise your hand. I'm not going to hold you to it. I just want to get a sense. Okay. Now, that's helpful. Please put your hands down electronically, and please, please raise your hand if you say you're not, for whatever reason. And by the way, if you're not comfortable, like you're like 3 or lower. I mean, if you're lower than 3 understanding on cross products, and that wouldn't be an admission of fault, because I don't think you were supposed to learn them anywhere, actually. If you're not wholly, but I do need to see the hands. The first choice was comfortable on cross products. The second choice now is not comfortable with cross products. Yeah, for example, like right-hand rule. Like if you're not totally hip, okay, there are definitely more hands that went up for not. That's good enough for me to go over it. All right. Yeah, the biggest, so I'm gonna, those of you who really are down with cross products, there's only 20 minutes left. I'm gonna talk cross products now. If you feel like you're pretty down with cross products, I will not be insulted if you leave now, honestly. I mean, you might benefit anyway by staying. I might have an opinion on that. But if you feel you're comfortable with cross products and you want to go study or something like that, I will not be insulted if you leave now, because I know we're not going to get anything else done besides cross products now. But yeah, you might learn something you didn't know before or whatever. So cross products, and particularly, what did I just do? Sorry. We're going to do cross products and particularly how the right-hand rule fits in. Where'd it go? I am going to pretend as I'm talking about this, in the interest of time, I'm going to act like you totally do know dot products now. Wait, yeah, because I think I got just far enough with them, and they definitely are in my solutions video, and they're not so bad. So I'm going to assume you kind of know dot products. Dot product is the scalar product between 2 vectors. It looks at how parallel 2 vectors are, and the classic example of a dot product is work, is the dot product of force with displacement, right? Let me just get. That's when I think of dot product, I think those things. So I'm going to pick up from there and build the cross product. Okay. Also, I forgot to, do I believe in Khan Academy and stuff like that, by the way? Yes, I do. Like, I don't consider using Khan Academy cheating in any way. I mean, until you're literally, well, I don't. But if you like Khan Academy and if it clarifies things like this for you, or you look up, then can I go one step further and say, especially when it comes to dot and cross products, if you think you're into this stuff and you know, you have some sense, but you really want some subtleties clarified or some intriguing, then I would go check out 3 Blue 1 Brown, I think it's called. Like the more sophisticated version of Khan Academy is 3 Blue 1 Brown. The guys that make that they're operating on a slightly more intense, higher level, and it's great graphics and stuff. So if you care, I don't consider any of that cheating, but if you're going to do Khan Academy, check out 3 Brown 1 Blue, I think it's called, or 3 Blue 1 Brown. They do a great job on dot products and cross products, but here we go. Like the way to understand, I'm gonna quickly recall our dot products, but I'm gonna do it through the unit vectors that we just established, through I, J, and K. Everything is easiest to understand through I, J, and K once you understand I, J, and K. So that's what I'm gonna use. Oh, question. So that's what I'm gonna do here. Like if you have 2 vectors, consider 2 vectors, A and B, arbitrary lengths, arbitrary directions. Right, and so they're arbitrary, but
Professor, I'm not sure if you're on your tablet, but we can't see.
Oh my God! Right. Thank you. Yes, I've totally been drawing my tablet, totally thinking you could see, and you totally cannot see. Thank you. Sorry. I will. Sorry. Lordy. You know, everything I learned in teaching school just doesn't apply anymore. Okay. All right, so thank you, sorry about that. But all I'm saying is we're gonna build cross products from sort of vaguely recalling something about dot products, but really what we're recalling is how unit vectors work in general. If you have two arbitrary vectors, A and B, right? They're separated by an angle theta. So you have two arbitrary vectors, A and B. We said that by definition, the dot product of those two vectors, the scalar product, is one way we could look at it, we said, was this. This is true, sorry. It's always true that if you want to look at if you want to measure the magnitude of two vectors to the extent that they are sharing a direction, then you multiply one magnitude times the other magnitude times the cosine of the angle between them, because you'll get a bigger and bigger percentage of their magnitude product the more and more parallel those two vectors are, the smaller and smaller the angle is. So in other words, the smaller the angle, the bigger the product, the dot product, the scalar. Okay, we said that, or I'm saying that we've said that, but from that, it follows that I hat, the unit vector that points along the x-axis, dot I hat, this is where we left off in class like days ago. If I hat really means some vector pointing directly along the x-axis divided by its own length, right? If that's what I hat means, it's like what we would have called x hat, but there's just too many x's in our life, so we made up a new letter and called it I. I dot I necessarily must equal 1. I hat dot j hat must necessarily equal 0. And because I dot I is 1 times cosine of 0, right? I hat, by definition, is a vector with magnitude 1. If I dot it with itself, I'm multiplying the length 1 times the length 1 times the cosine of no angle at all. So I get 1. If I dot I with j hat, in other words, the unit vector along the x-axis, I dot it with the unit vector along the y-axis. Now that's two vectors then that are fully perpendicular. They're as non-parallel as can be. In other words, I would get then 1 times cosine of 90, in other words, 0, okay? And I could make a similar statement for all the unit vectors. So when I dot, why do I care? Why am I bringing this up? Because that means even though, therefore, AB cos theta, that's one way to say the dot product between two vectors, but that assumes you know what theta is. It assumes that the vectors are presented that way. If the vectors were instead presented this way, if you had a vector A presented like this, and you dotted that, let me make this more clear, and you dot that with a vector right? Like, in other words, same thing, but now just if the two vectors were presented not as raw magnitudes related to some angle, but in fact as sums of individual components, if to dot out this whole thing, I mean, to dot these two vectors, I have to in effect FOIL out this whole expression. It's like it's a sum of 3 terms being multiplied by a different sum of 3 terms. So really what I'm going to do is do out all the combinations. I'm going to do like the first of the first times the first of the second plus the first of the first times the second of the first, etc. In other words, I'm going to do this. And those people who watch the solutions already just saw this, but I'm going to say, wait, can I do the next page? I'm going to say, I'm going to say that AXI, what's going on? AXI plus AYJ plus AZ dotted with this is going to equal AXI dot BXI plus, when I put a circle around something, it means like line break. So I'm putting plus with a circle around it, just means I'm continuing to the next line of what is still one long equation. So I have AXI hat dot BXI hat plus AXI hat dot BYJ hat plus AXI hat dot. Now this is still dot. I know people are asking about cross. Well, I don't know what people are asking. I know people really need to see cross, but if you see how to do it with dot, then you'll see how to do it with cross. AXI hat dot BZK hat plus etc. Like 6 more terms, right? Like what I'm saying is, if I want to really see how the dot product works or the cross product between two vectors expressed in unit vector notation, to dot two vectors, I have to FOIL out all the terms. I'm going to get 9 terms here. But the reason I'm stopping before I get all the 9 is I'm noticing a pattern that's super important. Like on this first term, I have AXI hat. So let me look on the next page. I'm just going to focus on the first term just to see something. Focus on first few terms, let's say. So first we had AXI hat dot BXI hat. Well, multiplication, if this is commutative, well, most multiplication, certainly dot product is. So I can rewrite this like this, AX. Okay, AX times BX times I hat dot I hat. These are all dots, but, and I hat dot I hat, we already said is 1. So the first term is simply AX BX. And that is going to happen with all of, if we look down the list of these terms we're generating, anytime 2 terms from the same component get multiplied, 2x or 2y's, they're always going to be dotting the same unit vector components. So we're going to get a bunch of 1s there, and those terms will simplify. Similarly, anytime we see a term, if we see a term, what about second term? The second term of 9 total, the second term was AXI hat dot BYJ hat, right? Well, what does that equal? Multiplication is still commutative, so it's AX BY dot I dot J. And these are all technically dots, but the dot of 2 numbers is just a product of 2 numbers. Now we said I hat dot J hat, that is 0, because those are orthogonal. Oops, I'm waiting with Dinah. Oh, sorry. I love this I. I love how you guys. Oop, is X I. I have a very good question in the chat here that may be too good for me to answer for the moment. I apologize that I can't answer that question. I will try to get back to that chat question in a second. But all right, so we have AX, so we have times 0. So this whole thing dies. The croaks, I mean, vanishes. Sorry, I have a 5-year-old. I don't like to say die in front of him. So what I'm saying is we're about to get 9 terms. This dot product, just the dot product, is about to look very complicated. But every one of those terms that has an I and a J, or 2 unlike terms, they're all going to cancel out. The dot product of I and J, or J and K, or K and I, is all 0. So all we're going to be left with, when we do out all these terms, this is the dot product I'm talking about, and I know then I've got 10 minutes to do the cross product. In the end of the day, A dot B will end up equaling AX BX, like that term will survive, plus AY BY, that term will survive, you know, with the dot product 1, and then plus AZ BZ, the dot product of 2 vectors, as you would maybe expect, or as hopefully makes sense when you look at it. All of that will turn out to be the same thing as AB cos theta. It just depends on what information you have. But if you have two vectors expressed as sums of their unit vector components, then the dot product of those two vectors will be simply the sum of the like components, right? That's what the dot product is. It's just, it's being very careful about direction and saying we're only going to multiply things that are parallel. But after we do that, we're going to add them all up and get one big answer. So this is the sum of like components. Okay, that's what the dot product always is in either one of these expressions. Like this, you could memorize and always use it's always right for the dot product, but this is also always right, and you can always, it depends on what information you have. Okay, how does that relate to the cross product? I'm going to do the same reasoning with the cross product now. The cross product does get more thorny, but it's the same reasoning. So let me first start by saying with the cross product, now cross. The cross product is supposed to be the other thing. The cross product measures a relationship between two vectors that does take into account direction. What does that mean? It means it takes into account the role that direction plays in relating one vector to the other. In other words, it takes into account how much the two vectors directionally differ. If the two vectors are directionally the same, if they're parallel, then they're just like numbers on a number line. We use the dot product to reduce this to regular multiplication. But if direction is playing a role in a situation, that means one vector is differing from the other in direction, and that we care, and we want to see that in our final answer. So our final answer, let's call, if we're going to cross two vectors, we want to return a value that says something about their relative magnitudes, but also their relative direction. Whatever that cross product is, let's call that thing C. Let's start by saying, or let's remind ourselves, sorry. Whatever the cross product is between two vectors takes into account their magnitude and direction, and gives us that information in a package of magnitude and direction that we call a vector. Like the cross product is supposed to return a vector that has magnitude and direction. Let's call that vector C, just for the moment, so I can make notation, use notation effectively. Whatever the cross product of two vectors is of A and B, assuming the same A and B we're working with here, we'll call it C, okay? Then, just like, or sort of like, A dotted with B always ended up equaling AB cos theta, I can say, just like that, I know I just flipped the page, but I'm going to say, given if we have this, and remember the two vectors are just two arbitrary vectors with different magnitudes and different directions. If we have these two vectors A and B separated by theta, right, but we don't know theta, we just know how the two vectors are written. Like each one is written like this in terms of its components. I'm trying to do this fast. I know I am aware of the time, which I'm not always. But assuming all this stuff, okay, if the two vectors are written in that form, then I'm going to say, okay, and I know I just went fast, but I think you well. I'm going to say, then the magnitude of the C vector will equal, as you might guess, AB sine theta. Like just like the dot product yielded AB cos theta, I'm going to say with cross product, we're looking at perpendicularity now. Now, if two vectors are separated by an angle 0, if they're parallel, we don't want the cross product to return anything. Oh, sorry. So if the angle is 0, we want a 0 answer. As the angle gets bigger and bigger toward 90, we want bigger and bigger answers. At a 90-degree angle, when the two vectors are fully perpendicular, we'll get a sine of 1. We want and we'll get to 100% of the product of the two magnitudes. So if you were guessing, if you understand why cosine is used with the dot, you would maybe guess that sine is used with the cross, and you'd be right. Just let's be clear, I'm saying, if you multiply A times B times the sine of theta, you don't get the cross product, you get the magnitude of the cross product, because the cross product is a vector. What's the direction of, and this is where we're almost, like this vector, which represents the cross product of A and B, will also have a direction, and we need to know that. Notice I didn't stop and say this about the dot product doesn't give you a vector. So you don't have, there is nothing at the end that has direction. You just literally get AB cos theta. But what's the direction of the resulting cross product vector? That is that is determined by what is called the right hand rule. Some people have heard of this a million times. Some people have never heard it. Some people have heard it and ran away from it. First thing I want to say about the right hand rule is I am a physics guy. Like, I love physics, right? And math is part of physics, but I'm a physics guy. The right hand rule is intrinsically a math thing, not intrinsically a physics thing. When you hear right hand rule, if you automatically think of like a magnet and a current or something, you actually might be distracting and confusing yourself. Don't jump to any physical thing. What the right hand rule is literally a convention that tells us how to determine the direction of the answer when you cross any two arbitrary vectors at all, physical or non-physical. What does the right-hand rule say? Well, it says this. What the right-hand rule is really about is the fact that the cross product one measures perpendicularity between vectors, right? The more perpendicular two vectors are, then the bigger the cross product will be. Bear that in mind. And then number two, bear in mind that the cross product itself has direction. Given those two things, and given that the cross product, like the dot product or like any other product, should be some operation, some measurement that we can perform on two given items, in this case, two vectors. And if it's a fair operation, we don't want that operation to favor one of the two items more than the other. Like, whatever the operation does to these two things, it should do it the same to both. So we've got this measurement that's going to see how, like, the more perpendicular two vectors are, the bigger this return should be. And this return should somehow indicate what the directions of those two things are. Like, our answer has to take into account the directions of the two original vectors in some fair way. So when you really think about it, our final answer, whatever direction it points, well, it shouldn't point closer to one vector than the other. Like, our final answer shouldn't point 30 degrees northeast. If one of our vectors pointed 29 degrees northeast and the other pointed 90, there's no reason our answer should favor one of those two angles more than the other. Our answer shouldn't necessarily shouldn't lead us closer to one of the two original pieces of information than the other. So what would be fair is if our answer were necessarily, say, 0 degrees or the same number of degrees from both of the original. If C were the same angular distance from A as it were from B, that would certainly be a strong indication that the operation was fair. But that's impossible in almost all cases. Like, if one vector points at 15 degrees northeast and the other points at 25, how are you going to be like parallel with both of them? Or how are you going to be 1 degree from both of them? You can't. What you can be as an answer is 90 degrees from both of them. If you think about it, for any two vectors, right? Any two vectors whose directions we want to take into account, like we want the information of their directions to go into this calculation and be revealed somehow by the answer, then what I'm going to say is that the vector that is our answer, if C is the vector that is our cross product between the two, I'm saying then that the direction of C will be perpendicular to A, and it will be perpendicular to B. And as long as I can figure out a way to do that, that will be great, because it'll be equally far from each original angle. So it won't favor either of the angles equally. In fact, by making it perpendicular to both, I'm also doing a nice thing, because the whole thing was supposed to measure perpendicularity in the first place. So it's like each of the two angles, each of the two vectors, I'm asking, how perpendicular are you? And I'm getting an answer that is perpendicular to both. Is that possible? Sure it is. Anytime you have any two arrows at all, like my A and B here, wherever I drew these two arrows, however I drew them, there's always a plane that contains both of them, right? Like my blackboard here. I could tilt my blackboard, they're still both in the plane. Two vectors uniquely define one plane necessarily. I'm saying the answer to a cross product will be perpendicular to that plane, because by being perpendicular to the plane, it will be perpendicular to both of the original, and therefore favor both equally in its directional computation. So whenever you cross two vectors, the answer will be perpendicular to the plane of those two vectors. The only question left is, will it point out of the plane or in? Like there's only one axis that will point along the line I'm looking for, but what's positive and what's negative on that axis, that's the convention that is adopted by the right-hand rule. The right-hand rule really is important, but it's just so that we all establish the same positive direction on an axis that is knowable and seeable even without the right-hand rule. The right-hand rule says, and this is where we're going to end today, just about, I think. The right-hand rule says that you place your fingers along, if you're crossing vector A into vector B, then you follow the order, you take it seriously, you place your fingers of your right hand, you place your fingers, this is so awful, along the first vector, and then you curl your fingers toward the second vector. Order does matter. So the right hand rule says, I'm going to take my fingers of my right hand, even if I'm a lefty, I'm going to point them along vector A. Then I'm going to curl my fingers, like bend them in a natural way toward vector B. And whichever way my thumb is pointing, that is the positive direction. That is the way in which the cross product will positively point. You'll notice if you do this right, if I take my fingers and point them along B and curl toward A, my thumb will point the opposite way. It'll be on the same axis because there's only one axis the answer could lie along, the one perpendicular to the plane. But which way the answer points on the axis depends on order. Now the right-hand rule never made any sense. That's what the right-hand rule is. It just tells you which way to assign positive on the answer to a cross product. And it's just there so that we all get our positive convention, like internally consistent. I never understood the right-hand rule until I did, meaning that people always say, place your fingers along blah and then curl toward blah. No one ever knows what that means. This is what that really, when it says place your fingers along A, the reason people don't actually try this in private or give up on it is because, in fact, that's totally ambiguous. If you place your fingers along A or try to, there's a number of ways you could do that. Like I could rotate my wrist in all kinds of ways. I could have my fingers pointing along A so that they're sort of slicing into my blackboard, or I could have my palm of my hand flat along the blackboard and my fingers would still point along A. It seems very ambiguous. What the rule is actually trying to say is, yeah. Play with your fingers. Note that your fingers can do whatever they want along A, but now hold your hand in some way so that your fingers can actually curl toward B, so that your fingers can bend at the knuckles toward B. Put your hand on A so that your fingers can bend toward B without doing something anatomically hazardous or awkward. Like, make your hand so that the fingers can curl toward B is really what the right-hand rule is saying. Then your thumb will find itself in one and only one orientation. If you don't break your body or do something really contorted, there's a million ways to place your fingers along A, but there's only one way to place them along A such that you can curl them toward B. That's what you want to try to do. And wherever your thumb points, that's the positive direction of the answer. If you get what I'm saying, you'll realize you don't need your thumb and your fingers for anything other than to distinguish positive and negative, like you would have already if you get this. But that's the right-hand rule. So the cross product between two vectors, technically, and I know I'm going to go like 2 minutes. It's 3:57. Let me just technically. So we have this given any two A and B. We have that. This is a summary, and then we're going to stop. A dot B will be equal to AB cos theta, which will also be the same always as this. This is a summary. Okay, the dot product always returns a number which is simply expressed in one of these two ways. A number, 1 or 2, equivalent. But the cross product, if I write it similarly, if I do everything else, the cross product between the same two vectors, and any two vectors you can dot or cross as need be, the cross product, well, the magnitude of it will equal AB sine theta, the magnitude of the cross product. The direction of the cross product, if I put like a hat over it, and you see this is so awkward, that's why I invented the little C and said C equals A cross B, just so I didn't have to write this awkwardly, but the direction of that is equal to the right-hand rule. And finally, then, if the vectors are written in vector notation as we're doing, this is the long part I'm going to abbreviate for right now, but just as AB cos theta turned out to be equal to AX BX plus blah, 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 we could FOIL out, I'm going to say this, I do this if you watch the video on going over the test, I do this, but if we actually FOILed out, I promise this is the last thing I'm doing, if we did A cross B equals this. Cross. If we do this all out, which is the one last thing I have to do, B, C, K. If we do this all out, term by term, again, we'll get 9 terms. Let's look at the first one. AXI hat cross BXI hat, right? That would be like the first term. And then just do one more. The second term would be like AXI hat cross BYJ hat plus etc. 7 more terms. If you look at these now and go term by term, the ones with like components, these will cancel out to 0. With the dot products, the like components survive. With the cross product, the like components appropriately vanish, and the unlike components survive. And so you have things like I cross J, no, sorry. Now, I cross I, it's the opposite of dot, is necessarily 0. 2 vectors that are parallel with each other, one vector that's parallel with itself, when you cross it, you get nothing. But if you do like I cross J, okay, you'll get a vector whose magnitude is 1, but which is still a vector, so still has some direction, a direction which must point perpendicularly to I and J according to the right-hand rule. In other words, I put my fingers along X, curl them towards Y, and my thumb points along the positive direction of the answer, which of course would be K. If you think about it, you might think the answer is 1, but the cross product of I and J is K. The cross product, similarly, of J with K will give you I. This is what the right-hand rule means. And by the way, J cross I or something would give you negative K. Okay, I'm doing this fast, but that's according to what we just said about the cross product. So if I do out all these terms, if I do out the 9 terms, I'm not going to do them out now. You should do them yourself as an exercise or whatever. But if you FOIL out all 9 terms of the cross product, and if you cross out all the ones that end up being 0 and you leave the ones that don't, you'll end up with a bunch of I terms, a bunch of J terms, a bunch of K, and you collect the I, J, K. Well, you'll end up with 2 I terms, 2 K terms, 2. Anyway, and this is what you'll end up with. I just know that. I mean, you can show this yourself, but you'll end up with then, and this is literally the left, then A cross B will end up looking like this. If you just FOIL it out, you'll get A, Y, B, Z minus A, Z, B, Y. Do not try to memorize this, but you will eventually by accident if you get a plus. It is a pattern for sure. And you can also do this with a matrix if you like that better. A, Z, B, X minus A, X, B, Z, J. So this is a mouthful. This might be the most complicated expression that you've ever really had to use a lot in the class. And you do have to use this a lot, but it does make sense once you, and it is also where we're ending, but this is the cross product. And then you can just fill in it, you just plug and chug once you have this. And then we're done. A, Y, B, X. It is a pattern, but it's what happens if you FOIL out all the terms and you collect all the like terms that survive after the zeros. Okay, I know I'm over, and I know Professor Wu is like hating on me almost as much as I love on him right now. I will, if you come to the more concise and prepared, if people study a lot tonight and take advantage of it, if you come tomorrow with like concise, questions, I will answer at the beginning, but then I'll move on. So please do come if you have quick questions, but I won't set up breakout rooms or anything like that. Just if you have, and then we'll give out the test after tomorrow. You give it back Friday. Everybody be happy. Let me just look in the chat quickly to see who I've read. But if you have to go, please go, please go. Oh yeah, see it again. Yes, yes, yes. Do you want me to go back to like, well, let me make clear. This screen right now is the final answer of the cross product. Like if you want to, and I will publish these notes again, but is this what someone wants to see or someone wants to see a page before? I mean, I think this is the, I could also write this more neatly, but it is a pattern. You should not see any repetition. You should see yourself cycling through Y, Z, Z, Y, Z, X, X, Z, X, Y, Y. But anyway, quick questions. Are we good? Yeah. All right.
Right-hand rule, how would we know which vector to start on?
Oh, yeah. No, great question. It, literally, by the way it's written down, like if someone asks you what's A cross B, you literally start on A. But if they ask you what's B cross A, then you do it the other way, right? It's literally that, yeah. So it's technically anti-commutative. But that's the only way to know, right? Okay. Great question. Any other? Cool. So yeah, it's just literally the way it's presented. Okay, I think to protect, just in case, I'm gonna hop off. Okay, I will send around the recording of this, or I think this is, yeah, I'll put it on the YouTube and the Vimeo, whatever, and I will send around PDF of the notes from today if they help or not, and I'll try to update the solutions with like just more clarity, but I'll try. Okay, thank you guys very much. Oh, and then what?
On if you give us a
sorry, go. I'm sorry.
A question like this on the exam, would you want us to do the whole justification and write out all 9 terms and then cross them off?
Oh, that's a great question. That's a really great question. No. Very fair. I mean, I could see, no. I want you to see where I got, like, you would at least have to, you could start, if you did a cross product, if you started literally from this level that I just wrote down, that is fine. You don't have to prove this. You could just write this down, but I'm not writing this in the equation sheet. So one way or another, you don't have to derive this, but I think it's hard to memorize this and get it right every time unless you somehow understand where it came. But right, you don't have to derive. This thing that's written on the board right now is a perfect, fine place to start any cross product from. Right, that's a fair question. Yeah.
While you're doing answers for the review sheet, while you're making them on a sheet, would you be able to specify, like, I know a lot of times we have to write certain givens that are needed for each question. Would you be able to specify like which givens you want us to show? Like, let's say, for example, just so we can cross-check our work, so we have everything included in our notes. Like, let's say, for example,
I'm sorry.
You need to write like the summation of all forces equals MA and all these other kind of things, or is that supposed to be just something we're supposed to know?
Yeah, no, that is a very fair question. That's a really good question, because that is, I have to be honest, that's where I'm a little bit harder to predict. I mean, no, I actually do. I think you do have to write down givens like F naught equals MA, like the stuff that might seem really, really obvious. If you're using it at all in a problem, I do want you to write it down. That doesn't mean it might not be in the equation sheet somewhere. Like F equals MA is in the equation sheet, but every time you're using it, I do want you to write it down. Anything you're using, yeah, I want you to write down, even if you think you already know it or something. Now, I will admit, that's where the issue of what is given and what is not is sort of starts getting into some subtlety. Sometimes it's hard for me to give an exact rule of how to know what's given and what's not. But I think anything you use to solve something, definitely do write it down. And the number of givens that there actually are that you need to write down in a given problem, I think is a much smaller list than it seems like right now. But I would say, like, every spring problem, you have to write down, if you're using F equals MA at all, you have to write it. If you're using F equals negative KX, you have to write it. If you always, the bottom line is, my best advice is, whether you think you know something or you don't, always start by writing the most obvious, most general, most fundamental thing you can, like definitions. Even if they seem so obvious, you should write them down first, because that's actually how you get the proof or the derivation rolling. Like if you do know it, then it shows you know it perfectly. And if you don't know it, you're not going to figure it out unless you write those things first. So yeah, it's a long answer, but yeah, I'm a little bit picky that I would, when in doubt, overwrite, don't underwrite in terms of an exam. Like, if you think nothing is too obvious, just give me more rather than less if in doubt. And that goes for crossouts people too. let's say really you're in a crisis, you really like you do a whole problem one way and then you like do it a whole other way and you really can't decide which. At worst, give me both. And then sure, you have to make a preference so I can grade, but I'll give you credit for other alternative views that you can't decide between if you show me your thoughts. So yeah, when in doubt, write more, not less. Oh, and definitely someone just asked, this is really important. Yes, you can do your exam in your handwriting. Please, I want everybody to understand that. You do your exam, whatever's most comfortable for you. I suggest that you do drafts first, of course, but definitely do it in pencil or pen or your handwriting. Only thing I'm saying is do it on separate sheets. Don't try to squeeze your answers into the sheets that I'm giving you guys. I should say that again tomorrow. Do it on separate sheets, but do it in your, however you want, just then scan it in so I can read it as a PDF. But you definitely don't have to kill yourself to type or anything like that. Also on that, wait, there was something, well, no, I guess that's, I mean, the best way to study, like, you'd be surprised, again, good students always are, but really the first thing to do is just try to do out those problems in the exam, just literally the ones that you even have solutions for and think you know, just try to do them without looking. The more you think you know something, just try to do it without looking, because it'd be so satisfying to find out that you're right, but it'd be so important to find out that you're wrong. Don't assume you get something just because you see what I'm doing. You want to try it on your own numerous times. And also to everybody, if you do the same thing 3 times, like my question, don't say to yourself, this is a waste of time because he's going to change the numbers. It's not. I will. But if you do my numbers 3 times and you know them cold, you won't be thrown when I change the numbers. But anybody who like keeps trying to do a million other examples and never does the original examples will be thrown. Anyway, I'm talking too much. I think I hate this because everybody feels like they have to stay when I talk when they really don't. Wait, so one more chat. Whoever just sent around a link, thank you. That's awesome. Cool.
That link on the screen, but it explained a lot of what you said as well for like the cross product.
No, good. No, please. I love the fact that you're sending those things to people. Like, that's great, and other people are too. I mean, again, when I have recommendations, I'll add, like whatever works to explain these things. But okay, I will go now. Bye. Okay, bye everybody.